Good morning, everybody. Absolutely delighted to see the room full for this morning's very exciting event where we will take a journey together to learn about this fantastic new and innovative technology that's got so much application in the public sector and indeed for the economy and in the private sector. I'm Sam Beckett. I am Deputy CEO at the Office for National Statistics. And I'm absolutely delighted to welcome you here, and also on behalf of our co-hosts, the Geospatial Commission and the Satellite Applications Catapult. It's an absolute pleasure for our three organisations to welcome you here for this symposium. So, the broader context, I'll just take a few minutes to introduce. I mean, we know from UK Space Agency data that Earth observation supports about £106 billion of economic activity every year. Now, that's roughly 5% of GDP. Now, I think that's an absolutely incredible figure. As an economist myself, I kind of get that 5% is that's a big sector, but there's still so much untapped potential for it. And that, I mean, really, that is why we are here today. In the public sector, it offers opportunities to revolutionise how we locate ourselves to deliver public services, and of course, close to my own heart, how we produce more timely, more granular statistics that support decision making, be that in the public sector or private. So the government has recognised this opportunity. They've put in place some of the structures and frameworks that are required for success to deliver this potential revolution in economic and social potential. The National Space Strategy confirms the commitment to Earth observation technology and the sector. And the Geospatial Commission, our co-hosts today, are there precisely to unlock this potential. That's about Earth observation and so much more in terms of data and measurement. The Satellite Application Centre has been established to fast-track the adoption of this technology so that we can harness that untapped potential as rapidly and successfully as possible. In the Office for National Statistics, we have been really trying to harness and understand the potential of Earth observation and satellite imagery in particular. Just to give you a tiny example, we find it. We have our census once every 10 years, but some populations are really hard to capture. That's very based on a household response. We've been using, as a pilot, this technology to look at how many people are living in caravan parks, an area that is growing rapidly and where we've been, unable to be assured of the quality of our measurements. That's just a tiny example. We've also been using it very much in the work we do in terms of international development, using it to look at livestock patterns and to think about innovative ways of measuring economic development and in middle and low income countries. But we know we're just at the start of our journey. But our commitment as a National Statistical Institute is very much about this better location data, more granular data, because one layer of our statistics that we feel is underserved is that local level, the subnational picture, and that's where some spatial data of every kind is incredibly important to us. And we have, for the first time, now established a network of ONS analysts right across the UK, co-located in the regions and the devolved governments to bring alive the demand for that subnational data and to supply it to the best of our ability. So look, the purpose of the day is to bring together an audience that by collaborating, by understanding each other's challenges and brainstorming how they might be solved, will really bring alive this potential. We've got very diverse backgrounds in the room, obviously the public sector, but academia and industry, and that's the challenge. You know, do speak to each other in the breakout sessions and over the networking lunch, and try and collaborate to find the synergies in what you're trying to do and overcome each other's challenges. We've got a couple of really exciting panels today, one focused mostly on the public sector challenges and the other from the industry leaders. But that's all I'll say today. It gives me great pleasure to hand over to our keynote speaker, Viscount Camrose, the Parliamentary Under-Secretary of State in the Department for Science, Innovation and Technology, and Minister for AI and Intellectual Property. Thank you very much for joining us.
Right, well, good morning, everybody, and thank you very much to Sam for the introduction and for setting the scene so well. I think it's really a deeply exciting morning that you're going to be spending together. I would also like to thank the teams at the ONS Data Science Campus, the Geospatial Commission, and the Satellite Applications Catapult for their collaborative efforts in bringing today's exciting agenda together. And of course, the magnificent Geovation Hub for hosting us. So, as Sam said, I am Parliamentary Under-Secretary of State in the Department for Science, Innovation and Technology and Minister for AI and Intellectual Property. And it's a bit of a mouthful, but I keep repeating it in the hope that one day I'll know it by heart. But as part of that, and a really important part of that, I'm really proud to be the minister responsible for the Geospatial Commission, and I'm delighted to be here today to talk about the importance of Earth observation data and technology to the UK, and some of the ways the government is supporting this really important part of our economy. And I'm particularly excited by the many opportunities that new technologies and innovations are going to be bringing to this space. It is great to see, it really is great to see so many of you here today from across the sector who I think share my enthusiasm. EO data and tech are already playing a pivotal role in environmental and land use monitoring and in enabling coordinated international response to disasters overseas. Today will, I have no doubt at all, be a showcase and celebration of what EO data and technology are already doing for the UK economy, but also its potential for the future. And as Sam has set out, it's going to be hugely beneficial for all of us to reflect on the diversity of views and expertise here today, from academia and the public and private sectors. I'd echo her challenge to us all to think about the connections we can make and what we can do together to ensure this sector continues to thrive and continues to grow. So the UK has a vibrant and diverse Earth observation market. We are world leading. Global demand for this technology continues to evolve, as you all know, at a rapid pace. As the cost of data capture has decreased, many new sources of this data have opened up across a range of platforms, resolutions, and spectra. Last year, the government announced up to £200 million of funding to invest in the UK EO sector to maintain our competitive advantage and boost activity and innovation. The funding is spread across 17 projects, which are going to benefit Earth observation scientists and firms across the sector, from developing new sensor technologies to using Earth observation data for improved understanding of climate change, as well as funding further skills training to ensure that we have a pipeline of talent for the future. The EO sector has high growth potential and produces vital science and data. Therefore, the strategic importance of building strong Earth observation capability on both the supply and demand side of the UK economy cannot be overstated. Figures in the latest Size and Health of the UK Space Industry Report show that in 2021, EO technology supported an estimated £106 billion of UK GDP. It's an amazing number. The National Space Strategy ambition is for us to strive to remain at the forefront of Earth observation tech and know-how as part of our bold vision for the UK in space. I know my officials are working with many of you to develop sector priorities for Earth observation, to give the UK a clear, longer-term direction, and to help achieve that ambition. Our work in this area is also a key part of DSIT's commitment to positioning the UK at the forefront of global scientific and technological advancement to sustain growth and drive innovation in public services. The Geospatial Commission aims to unlock the value of location data and technologies in the UK and bolster the UK's global reputation as a key geospatial player. As part of this work, to understand key geospatial markets, the Commission seeks to unlock growth and reduce barriers to supply and demand of high potential tech. Earth observation satellite data is just one such example of this, and a commitment was made in the 2025 UK Geospatial Strategy to explore public sector procurement of this data. Last year, the Commission co-funded research with the satellite applications Catapult that evidenced increased demand for EO data in the public sector and highlighted key opportunity areas. The report also recognized how EO is underused in the public sector due to existing barriers, including varying levels of technical understanding and the challenges around keeping pace with a very rapidly developing market. To unlock the potential of Earth observation in this area and drive innovation, the Commission is now running a 12-month pilot to provide commercial EO data and services to the public sector. That will give public sector users across central government, agencies, local authorities, and police forces the chance to test what they can do with high-resolution EO satellite data. Some of these organizations are familiar with the data and they want to push the boundaries of their work. Others are working with this data for the first time and are seeking to break new ground in their own areas. And I'll highlight just a few of these. Established users of EO data seeking to innovate further include the Cabinet Office, National Situation Centre, who require access to recent high-resolution imagery to support crisis response, and the Rural Payments Agency, who require EO data for land use observation and crop productivity forecasting capabilities in the future farming and sustainable farming initiatives. But at the other end of the spectrum, the Coal Authority, as a newer user of EO, has expressed interest in using data enabled by specialized sensors, synthetic aperture radar, and very high resolution optical imagery for terrain investigations to aid responding to and monitoring ongoing hazards in coal fields. But the pilot is not just for experimentation. We really want the public sector to be innovating and driving efficiencies with EO data for the long term. Through the pilot, the Commission will be determining what kind of EO data the public sector needs and developing a commercial approach that supports this goal. We also want to understand the fast evolving EO market to identify growth opportunities, test solutions that lower the barriers to entry of EO data for the public sector, and help the market understand what their customers actually need. So, let me finish by saying that I hope very much you enjoy this morning's discussions around the exciting potential of this technology, make important connections with each other, and finally that I wish the Commission and all of the participating organizations really great success in this pilot initiative. And all of that said, best of luck to you all, and I'm pleased to pass back to Sam. Sam.
Thank you so much, and thank you for your time and joining us today. And it's very exciting to be here at the beginning of the launch of this Earth observation data access pilot. We all talk, don't we, in the public sector and I'm sure in the private sector about being truly data driven in everything we do and all the decisions we make. Well, this pilot is going to really bring that alive in this area and really set the challenge and push the boundaries of using new and innovative data to drive decision making. So, on the ONS's behalf, but I'm sure on everyone's behalf, we're really excited about playing a part in the pilot and making a success of the initiative. So not long until we start our first panel, but before we do, I'd like to hand over to Peter Beaumont from the Satellite Access Applications Catapult to share a few thoughts on Earth observation capabilities in the UK. Thank you, Peter.
Thank you very much. And certainly on behalf of the Satellite Applications Catapult, I'd like to welcome you all here today. It's good to see new faces and many old faces. So I'm Peter Beaumont from the Satellite Applications Catapult. I'm the director for our civil government engagement. And as one of the Catapult network, for those of you that don't know, we're a technology innovation center. And we're focused on ensuring that the UK is maximizing the opportunity that can be derived from satellite applications, data, and technology. And our role essentially is to energize the market. It's to empower the technology and actually enable businesses to develop new products and services. And we're very privileged to sit at that intersection between government, academia, and industry, enabling strong collaboration which will lead to economic growth and improved efficiencies in terms of how people make use of these technologies. So my role is to work closely with colleagues across government to ensure that the opportunity to gain efficiency and deliver more effective services and development of policy takes place. And to ensure that government is using trusted data and applications from space and starting to purchase those services from UK service providers. Now, in terms of the UK economy and the Earth observation opportunity, as both Sam and the Minister have said, the amount of GDP underpinned by Earth observation is considerable. But if we look at our own research, and some of you will be familiar with the Space Capability Catalogue that we maintain, there are over 290 businesses now in that catalogue that offer at least one form of Earth observation capability, application, or service, many of them offering multiple. So it's a very, very strong capability that we have in this country. And as was mentioned by the Minister, we do have world-leading capabilities, not only in terms of our commercial offerings, but certainly in terms of our academic offerings. And if we look at the Space Academic Network, there are 43 universities part of the network, and there are over 15 who have considerable Earth observation capabilities. So driven by new emerging technologies and increased technological capability, the Earth observation imagery and services sector is continuing to develop rapidly, both in terms of imaging and processing capabilities, but also in terms of service and business models that are emerging to meet the demands of the customers. This is reducing barriers to the entry for the use of Earth observation data, and is creating new opportunities not only for the private sector, but new opportunities for the public sector to unlock additional value from this technology. So why isn't it being used more? It's a question we all ask. And as was mentioned earlier, we did some research that we co-funded with the Geospatial Commission last year, investigating UK public sector demand for Earth observation technology. The study considered over 300 public sector organizations, of which 125 were either current or potential users of Earth observation data, which is a significant proportion of the public sector. And across these organizations, we identified around about 136 active use cases which were documented. And what's particularly encouraging was 62 of these were categorized as operational use cases. So this is where government is already unlocking value from Earth observation and using it to deliver more efficient and more effective services. However, during the interviews, there were challenges that were identified. I wouldn't say there were barriers, but challenges that we as a community all need to work on to make sure that the technology and the data can be used. There was an understanding that the capabilities of new data systems were either unknown or potentially misinterpreted by the end users. There was limited awareness of the maturing technologies, and there were challenges around understanding how to develop a business case, a robust business case. And there was a blocker for many users was around the cost of the data. There were also challenges around understanding the licensing agreements, and particularly understanding how data that had been purchased could be shared across organizations. But coming out of that, there are a number of opportunities and recommendations. And if we think about the 3 high-level recommendations in the report, and I would recommend that if you've not read the report, please do download it because it goes into a lot more detail. Number 1 was explore how current services providing access to open Earth observation data can evolve and be positioned to efficiently meet the growing demand. And we're seeing the work now being done both by the EO Data Hub and also by the Geospatial Commission with their data pilot, is starting to open up data and make it available to organizations. There was a recommendation to assess the investment case for coordinated procurement mechanisms for commercial high-resolution Earth observation data to meet the current and emerging policy requirements. And there was a recommendation to enhance knowledge sharing, and we can never do enough knowledge sharing. It's super important. And more collaboration between UK public sector bodies to encourage the greater uptake of data amongst those organizations with a lesser or a moderate Earth observation maturity. And that's really what we're doing here today. So why should we all be excited? There is so much work being done to support these recommendations across many organizations. We hear today what the Geospatial Commission is doing, the UK Space Agency setting the National Space Strategy, the Department for Science, Innovation and Technology with Space Directorate defining the capability goals that are required, the Ministry of Defence with their Defence Space Strategy. And the support from the government geography profession is super important, with the tireless work being done by Earth observation and geospatial data scientists throughout the public sector. So events like this symposium help to support knowledge sharing and ensure that government are aware of the products and services that are available from industry. The forthcoming EO data pilot will help to inform the development of more robust business models and support future investment in centralized procurement. Projects like the EO Data Hub will support improving access to the data. And this is all underpinned by a broad range of government strategies for AI, for innovation, international technology strategy, international development, etc. So why Earth observation and why now? Earth observation emerging capability? Well, we could argue not really. No, we've had Earth observation data on a regular basis since the first Landsat satellite was launched back in July 1972. But we are seeing many changes in both the availability and different types of remotely sensed Earth observation data, and the innovative use cases that can be supported. And we'll hear much of this during the day from the speakers following. And it is super exciting to see Earth observation data capabilities coming to market or maturing. You just need to look at the London-based Seraphim venture capital fund, probably the global leaders in space tech investment. And if you look at the Earth observation investments that they've been making around the world, satellite view, soon to launch high-resolution thermal data, opening up many innovative use cases, particularly when we think about things like building heat loss or urban heat islands. Look at Pixel, organization launching a constellation of hyperspectral satellites, opening up opportunities for more granular feature classification. And I'm sure we'll hear more about this from Planet in presentations later on. We have ICEYE with maturing synthetic aperture radar applications. And we're seeing partnerships with the leading optical suppliers linking up with synthetic aperture radar suppliers to provide fused data offerings. Look at Hawkeye 360, one of many organizations offering radio frequency capture. Super strong dual use offerings here, applications like illegal fishing. And it's an area of Earth observation that I would say is still to become part of a standard toolbox for many practitioners in the industry. And then we see organizations like CHAI or CH.ai focusing on the operational use of artificial intelligence-driven commodity insights, utilizing Earth observation. So in summary, it really is a truly exciting time to be involved in Earth observation. The advances in both public sector and private sector data offerings, combined with advanced compute, storage capabilities, enabling the effective use of artificial intelligence, is bringing Earth observation and geospatial data science to the center of many of the solutions and the conversations that we're all having today across government. We do have a very vibrant and world-leading Earth observation sector here in the UK. So think about the opportunities and the challenges that you face in your organization as you listen to the talks from the panelists later on today. Ask questions and make sure that when you leave here today, you're armed with more knowledge to make a difference in your own organizations. Thank you.
Thank you, Peter. And I think you'll agree, those two speeches have really set a very firm foundation for a successful rest of the day, with two panels still to come. So thank you both very much indeed. I'm just handing over to Osama now. I think you are taking control of our first panel. That's what my excellent brief says.
John, you want to join us? I'm going to sit here because Jacinta can see me when I'm waiting. All right. There you are. Good morning, everyone. So I'm Osama Rahman. I am Director of the Data Science Campus at the Office for National Statistics. And our first panel today is around Earth observation data for the public good. And I'm thrilled with the fact that, given that this is about Earth observation, we have a global panel with us today. So I'm going to do introductions, going to people online first. So first we have Arman Katchian. Professor Katchian is an assistant professor of economics at the University of San Francisco. He has kindly given up his early morning, because it's about 2 o'clock in the morning in San Francisco, to join us today. Professor Katchian completed his dissertation at the University of California, San Diego, and his research uses machine learning models on daytime satellite imagery to measure US neighborhood level growth, which links into the stuff Sam was saying about what we're trying to do at the ONS in terms of hyper-local measurement. He's going to talk today about from raw daytime imagery to urban policy insights. Next, we have Professor Jacinta Holloway-Brown, who's giving up her evening to join us from Adelaide. She is an assistant professor in the School of Computer and Mathematical Sciences at the University of Adelaide. She also used to work for the Australian Bureau of Statistics for many years in methodology and macroeconomic statistics roles. Her current research is about working with imperfect data and models to better monitor the environment. She's passionate about using methodological tools and free data to inform the UN and World Bank Sustainable Development Goals. And she provides advice to UN expert groups on ground truth data collection and satellite image analysis. And so today she'll be talking about measuring the Sustainable Development Goals. Professor John Remedios, who's on my far left here, is director of the National Centre for Earth Observation, which is hosted in the Earth Observation Science Group at the University of Leicester. I think it's well known to quite a few people here. He's a physicist by background, but he's worked with chemists and geographers and biologists, and his experiences in satellite data for observing the Earth, whether it's climate, land and ocean temperatures, air pollution, atmospheric gases. Again, no stranger to government. He is an advisor to DSIT, the UK Space Agency, and DEFRA through various advisory committees. And today he will be talking about numerical and spatial views of UK surface temperatures and heat risk. And then finally, I have Dr. Owen Daniel. Owen is a lead data scientist in the Data Science Campus at the Office for National Statistics. He has experience of embedding data science methods in 5 government departments, spanning policy and operational applications. He leads our teams working on data science around international development, health, and privacy-enhancing technologies. And he's going to talk about estimating populations of internally displaced people in Somalia. For those joining remotely, we do have a Slido link for you to ask questions, so we'll be taking questions from both the audience and from those coming remotely. I did realise that I forgot to discuss earlier what order we were going to go in with the speakers, but I think I did initially promise Arman that he would go first, so let's go over to Arman, please. Can't hear you yet. Yeah, can you try now? Jacinta, can you say hello? Let's see if it's working with you.
Sure. Hi, just testing if you can hear me.
Okay, we can hear Jacinta.
Okay.
Arman, we think it might be your microphone.
No, that's your computer.
Arman, can you rejoin us, log off and then rejoin it, and then hopefully that'll work.
Any chance you can hear me now?
Hey, perfect. Okay. Brilliant. There's always some technical gremlins.
Sorry about that.
Okay, no, nothing. So Arman, over to you. I will kind of wave. Can you see me?
Yep.
Okay, I will kind of wave after about 5 minutes, just so you know.
Sounds good. So you should see my screen now.
Yes.
Great. So yeah, I'm just going to talk to you a little bit about the sort of process that I've gone through with my research and how that connects a little bit to some policy insights that you might be interested in. So I'm going to sort of tell this story in four, it is a little bit late for me, in 4 images. And so the first figure here is just talking a little bit about the data that I'm using and sort of what we can hope to learn from the type of data that we actually use in this application. The second one is about how we modeled that data. And so what were we using to sort of infer useful information from that imagery and put it to some sort of policy application. The third one is the specific use that we did with this particular case. And so in this case, we were just creating predictions of places that did not have that level of data. And so I'll tell you a little bit about how we did that. And then finally, the policy application that I studied using those predictions. So that's the last piece here. So let me get into that. And so first of all, the data that I was using for this project was Landsat 7 data. And so you can see in the images on the left here that we have this data for 2000 and 2010. We also have it for other years in between and other years afterwards. But the nice thing about 2000 and 2010 is that we also have census data for those years. And so we can try to infer, we can try to figure out what features in these images are relevant to census data. And so specifically, you can sort of see in these images that they're not particularly high resolution, right? These are 30-meter resolution, meaning that we can say something about the type of land cover, whether it's urban land cover or farming land or other sorts of construction or geographic features. But we can't pick out, for example, individual homes or cars or anything like that. And so this is sort of early stage satellite imagery, and the things that are being released now that are coming online are much higher resolution and have much more potential for even more detailed analysis. So I'll say that, and I will also just say that we're not even using much of the temporal resolution of this data in the sense that I'm constructing annual composites. So I'm only having 1 image per year. Okay. And with those images that that we extracted through Google Earth Engine, we're creating this model. We're using a convolutional neural network. And the big picture idea of what we're trying to do with the model is we're trying to figure out what are the features in the images that are relevant for predicting 2 particular outcomes. And so the outcomes that I'm looking at here are population and income. Those are both measured at the block level by the US Census. So everything here is for neighborhoods in the US. And the idea is, because we have those ground truth labels in 2000 and 2010, we can construct a model using the imagery in those years. And that model figures out what the features are in the imagery that are relevant for the economic outcomes that we care about. I'll just say that a convolutional neural network is a good way to do that for two reasons. One, because you can plug images directly into it. And so you don't have to think about like flattening the data in any way. You can just plug images directly in. And two, because it actually takes advantage of the spatial relationship of pixels within an image. And so it kind of gets the context of like things that are next to each other in an image, and that can be very helpful for accurately predicting outcomes that you care about. Okay, so once we've constructed that model using all of these images for the US in the years that we have the census data, we can expand from that and we can create predictions. And so because this model is pretty accurate, we've tested it in out of sample data, and we found about a 90% R squared. We can be confident in using the predictions in other years where we don't have that census data. And so that's exactly what I'm doing here. Is this application is showing a map where there's fracking happening in the US. And the squares that I'm showing here are neighborhoods around those fracking areas. And so I'm able to basically fill in the census data for all the years where we don't have granular outcome data for income and population. And so it's a way of sort of filling in that gap of super local data that is normally only available every 10 years because that's when the actual census happens. And we're filling it in with the model predictions. And so finally, I'll just say that once we've done that, once we have those predictions for every year from 2000 to 2010, I'm able to study the effect of fracking on neighborhoods based on their level of exposure, both in terms of the intensity of the exposure and in terms of the proximity of the exposure. And so this graph shows very broadly that neighborhoods that were located within about 20 miles of a fracking well saw a negative 2% change in their population and associated total income, but it's basically driven by depopulation in areas that are within 20 miles, and a slight increase in population for areas a little bit further away. And so this is basically indicating that it's the effect of fracking in the US, at least, is on residential development is basically driven by this like general industrialization of the area, and not so much these like super high proximity effects like pollution or other things that are usually concentrated within about 1 mile. And so before we had this local data, we didn't really know what the spatial gradient of the effects of fracking were on economic outcomes. And by constructing it, I'm able to sort of speak to that particular question, the spatial gradient of the treatment effects in this case. So that's the broad story of what I'm doing here, and I'm very excited to hear your questions and get into some more details of how I did it and where I think this is going.
He's going to talk about measuring sustainable development goals.
I'm so sorry, I couldn't hear most of what you said, but I think you're throwing to me to present. Is that right? Okay, great. I only caught sustainable development goals. Okay. Can you hear me?
Yes, we can hear you.
It's a one-way thing. Oh, okay, great. Thank you. Sorry, it's the sound at the room is cutting out for me intermittently. Okay, I'm going to share my screen. Also, great presentation. I really enjoyed that. Okay, can people see that? Yes, Armin's nodding. Okay, thanks. We'll get started. Hi, I will be speaking about data science and Earth observation data for sustainable development goal monitoring. So the Sustainable Development Goals, if you haven't heard of these, are some high-level milestones that the UN and World Bank would like all countries to reach by 2030. And if we do these things, then overall life on our planet will be better. So these are really high-level goals, such as everyone having access to clean water and sanitation, taking care of life on land, which is something that I focus on. And these are all broken down into smaller sub-indicators. And in order to reach these goals, we need ways to monitor our progress. Otherwise, we don't know how we're tracking. So my research is about using free data sources where possible to do SDG monitoring. And primarily in recent years, I focused on forest monitoring, which is part of SDG 15, which is life on land, looking at trying to sustainably manage our forests and halt biodiversity loss, among other things. So there are a lot of challenges that we have when we're trying to do large-scale environmental monitoring, and primarily that's that the data does not want to cooperate with us. So we might have imperfect or non-existent data. It can be disparate and incomplete. We might not have enough. It's poor quality, or it's in the wrong places, or if we do have it, it's at different spatial and temporal scales. We might have limited or no available funding to collect more data, or in fact any data. And it can also be really difficult to access places physically in person to get the data. And that might be due to, seasonal effects such as flooding. It could be due to conflict in the region, depending on the area you're interested in. There can be a lot of barriers to collecting data in person. And so that's where satellite imagery analysis can come in and help us do the heavy lifting and overcome this challenge. Satellite images are available for free globally. They're a really useful open access data source. They allow us to find insights over large, remote and restricted geographical areas, so these places I mentioned that we can't get to ourselves. And as the sensors become more advanced, we have data at higher resolutions even more frequently. I spoke to a remote sensing scientist who said in the 80s it cost $1,000 for one Landsat scene, whereas now you can download the entire Landsat archive for free if you have enough internet and space on your computer, which is just incredible. So the problem that we have, though, is missing data, even with the satellite images. This is a visualization from NASA, from their cloud product. And so everywhere that you can see white on the globe is cloud, and everywhere that you can see blue, we're able to observe with an optical satellite what's happening on the ground. And a study from 12 years of satellite images once found that on average at any given time, 2/3 of the world is covered by cloud. So that's an enormous amount of missing data. It's not all bad news, but it does mean that we need to have ways to work around this problem, even for the free satellite images. So one way that this has traditionally been done is called compositing. And so essentially how this works is that when we need to fill in a missing data gap due to cloud cover, we take the previously observed values of the exact same pixels. So these are two images of the exact same area in Queensland in Australia, one from May 2011 and one from January 2008. And so what we would do under this approach is we would take the same pixel values from 2008 and paste that into the 2011 image. And we would treat this whole image as if it was all captured on the same date in May 2011. So obviously there are some problems with this. With time, the relationship between things decays, it's less realistic. And as you can see in this example, obviously the ground cover is a lot greener in 2008 than it is in 2011. And so you might be thinking, well, those years are so far apart, surely you would have an observed image within a closer time frame. And usually we would. This is a dramatic example, but in some places that have persistent cloud cover, it might in fact be weeks or months between images, and that makes short-term and really sudden changes very hard to detect accurately. So we need statistical ways to fill these gaps. And this is where my work comes in. So I did some really interesting work with Associate Professor Kate Helmstead and Distinguished Professor Kerry Mengerson, who are based in Queensland. And we made a new statistical machine learning method. So our method is called Stochastic Spatial Random Forest. It's really fast and accurate. It's scalable to millions and billions of observations, which is what you want with satellite images. It takes account of spatial information, so building on that idea that things that are close together are more likely to be similar than distant things. We can use it to fill in the missing data, which is really important. And probably the most important contribution is that it quantifies uncertainty, because when we're filling missing data, when we're trying to detect changes in the environment using satellite images, and anything in the environment, it is really uncertain. So we want to get some measurement of that. So the idea is built on the random forest algorithm, which essentially is an entire forest of simple decision trees. This is very interpretable. I think a lot of people are familiar with the idea of a decision tree. So for example, you could imagine one in your mind where you're trying to make the decision, do I take an umbrella with me when I leave the house today? And so one simple decision would be, or piece of information is it forecast to rain, yes or no? And then given that information, is it cloudy outside, yes or no? And so you sort of branch along these simple, smaller decisions to then make your overall decision. And that's a very simplified explanation of how the algorithm sort of works. It takes many of these very simple models and builds on that to make overall predictions. So our method addresses some concerns with machine learning because, like I said, I think decision trees are interpretable for many users. And also we give that measure of uncertainty. So we're not just giving a classification to take at face value, we give some bounds on that, and it's a posterior probability. I'll move it along. I don't have a lot of time. We did our case study in Queensland in Australia, which is home to 260 native Australian species just in this one little sub area. And so that's very important for our biodiversity. And we used Landsat 8 satellite imagery that we were able to get for free. And the results? Our method was much better at detecting significant changes, which we looked at in terms of simulated clearing events. So when you remove all of the trees and larger vegetation, and also a more subtle method. And so our method is in orange, and it is a lot more accurate, above 0.8, whereas the using only information from the past was significantly less accurate. And importantly, like I mentioned, ours quantifies the uncertainty in all the cases, whereas compositing does not. So to summarize the method, we can use it for any image in any region, provided that we have some training data, either in the past or currently. And we can also use the method to prioritize field data collection because we can make spatial plots highlighting areas of high and low certainty. And that's something I presented to the UN expert group on field data collection about last year. Currently, I'm working on sort of a branch off of this work, looking at Antarctic sea ice and combining the stochastic spatial random forest method with some climate models to try to get better short-term localized predictions. The reason that we care about this is because sea ice, particularly in the Weddell Sea, provides a really important buttressing of the Larsen ice shelf. And so basically, if you have less sea ice, it means that more of the ice shelf can fall into the ocean and melt, and that's actually what causes sea level rises. So we want to be on top of what's happening there, and there's quite a lot of uncertainty about sea ice in Antarctica. And this relates to Sustainable Development Goal 13, climate action. So to finish up, monitoring the SDGs is really essential to track our progress to these targets. Data science and Earth observation data together, I believe, are the really essential tools for this task. And with these methods and these data, we can explore and measure environments, for multiple SDGs beyond forests, anywhere that we have satellite images. Thanks very much.
Thank you, fascinating. And I think we'll come back to some of the issues around measuring the environment when John speaks. Okay, I'm going to go to Owen now, who's going to talk about measuring people.
Thanks, Osama. Whilst the slides come up, I'll address the elephant in the room. That's unlike the other panel members, I am not an expert in Earth observation. So I guess the reason why I'm on this panel is that my experience is really in taking data science innovation projects and actually ensuring that they really land in production in government, because we're still at that stage where data science is novel and new. We have lots of pilots, but actually getting it used in a sustainable way that can be maintained is a challenge. So yeah, all of the technical work and detail, my team are the experts. So, just to say at the start of this work, as the title says, this is about measuring internally displaced people in Somalia. And so there's a network of collaborators that we're working on this with. So notably, there's the Somalian government emblem there, but this work is also in conjunction with the Foreign Office, or the Foreign Commonwealth and Development Office, the UN, and our imagery providers, Planet. So I want to address first, why exactly are the ONS working on estimating populations in Somalia as the UK's National Statistics Office? So the UK has a commitment to international development, and in particular we spend 0.5% of GDP is committed to supporting growth in low and middle income countries. And one approach set out in the UK's international development strategy is to use our world-class expertise to support partner countries by providing them with advice. And that's very much the role that one of my teams in the ONS plays, of working with national statistics offices in a number of low and middle income countries to build their capability in statistics. And we do that in a number of ways. So the top image there has Sir Ian Diamond, our national statistician, speaking with colleagues in an NSO, so providing very high-level steer and advice. We also have interns and visitors. So the middle image is Tuli, who visited us from the Namibian Statistics Agency and spent 6 months working on Earth observation for agriculture uses in Namibia and has taken that experience back. And we also provide training and mentoring programs for upskilling in basic programming skills. So the project that I want to talk about today is about measuring internally displaced people. What are internally displaced people? They're people who've been forced to flee their homes, but unlike refugees, they haven't crossed a national border. So they're within their country, but not in their homes. And in Somalia, it's estimated that there are approximately 2.9 million people who've been displaced. And they've been displaced to over 2,400 different camps. And there are lots of different drivers in Somalia for displacement. It's been taking place for over 30 years. And they include conflict, climate shocks, and flooding. Statistics on IDPs are notoriously difficult to capture. Sam mentioned earlier in her opening speech about how in the UK's context, measuring people in caravans is hard. For similar reasons, measuring any migratory population is quite a challenging thing to do using traditional survey methods. And the Somalian National Bureau of Statistics report that there's a dire need to be able to have reliable IDP figures. And understandably, potential reasons for that are to A, inform and evaluate policy relating to IDPs, but perhaps more pressingly, to actually identify how much humanitarian need is required and to target those interventions in an appropriate way. The last census of Somalia took place in 1975, so it's been the best part of 50 years since there's been a census in Somalia. But there's one planned, which the UN are leading on in 2024. And so our work is really in support of that planned census to help estimate the population of IDPs, but also to help design the census, so to design the various sampling frames around how we go about counting the population. So, in terms of how Earth observation could be used for estimating IDPs, this is something that the UN already do. So the UN Population Fund, who's the arm of UN that leads on census work, they already use satellite imagery in Somalia to provide some estimates. However, they do that in a really manual and time-consuming way. So our offer here isn't satellites are new, this is going to solve the problem. That problem's already been solved. But currently it is done manually with people literally marking where settlements are on satellites. So what we're hoping to do is to automate that process through machine learning so that type of work can be done more sustainably, faster, but also more regularly. So at the moment, it's not feasible for UNFPA to create longitudinal statistics because of the time demands to actually carry out their manual method. Just to take the images there, so these have kindly been provided by Planet for us to share today. So in the top image, you can see lots of orange and white circles, and so those are tents typically. And in the bottom image, you can see more sort of blue structures, and those are more formal structures. And we're hoping to be able to distinguish between those in our work. This is work in progress, so I'm not going to show you any results, but I want to show you indicative results based on sort of what we're aiming to achieve. So on the left-hand side, we have a raw image from Planet, and then the types of outputs we're expecting to be able to generate as well as the sort of statistics, are identifying the types of structures and the probability that a particular pixel in the image is of that type of structure. So we can see here that we're classifying into non-buildings, houses, tents, and services. Finally, I'd like to just finish by sort of talking about the challenges, because as I said, I think what I'm bringing to the panel is really thinking about how do you do this for real in a sustainable way. And I think at this stage, we've identified 4 key challenges for this work about embedding this in practice. So the first is we don't yet know how accurate our methods are going to be. So whilst we aspire that we might be able to remove the human from the loop in terms of the current manual tagging that the UNFPA currently do to the images, I think more realistically, what we're going to be able to do is reduce the manual burden. But again, we don't yet know how far that will go. Another challenge is in terms of, in this type of work, you need a training data set. And at the moment, to generate the training data, you have to actually do the work by hand first. And so there's a question here of whether, at this stage, whether there'll be enough training data for our method to be truly generalizable to different camps in Somalia, but potentially, and much more interestingly, beyond Somalia, the potential for this work to be quite applicable in other places. The final 2 are really the biggest challenges, which is just really around institutional readiness. So Earth observation, as we've observed, isn't a new thing, but it is a new thing in some areas of government, and in particular in government and in developing settings. So there's a lot of work we need to do in building confidence that this approach to generating statistics is viable and an improvement on what we currently do. And finally, capability. So in the ONS, we have pools of expertise in Earth observation. So Chris at the back of the room is leading a lot of work that we do, and also my team. But it is still an emerging area which we need to build more basic skills in and more awareness of. And so my team, this work isn't just about us doing this work for Somalia and the UN. It's really, we will do this work and then we will work with them to ensure that they are upskilled to maintain and own this work going forward. And that's working with people who don't necessarily have backgrounds in programming. So it really is sometimes starting from the sort of start of data science journey. And that's it. Thank you.
Thank you very much. Okay. And now we come to John, who's going to talk about numerical and spatial views of UK surface temperatures and heat risk. So going back to the environment again, following Jacinda.
Yeah. Okay, good. Hopefully you can hear me online. I always love a fixed microphone. Never mind. I should preface this talk by saying already, based on what everybody else has said, I could think of 100 different things I could say. So some are going to try and stick to a few key points, but we'll see how it goes. I'm going to talk about actually a bit of a different thing, which is not just using the images, but actually using the products already derived from the images. And as a physicist, that's kind of where we come from. Let me just move on to one slide. Okay, so just one word of context here. So 2 things just to emphasise actually what Peter said. One is the UK has been doing Earth observation actually very high quality in its academic circles for decades. So people talk about measuring temperature of the Earth. The most accurate sensor to measure temperature of the Earth, and not a lot of people know this, it's actually designed and built in the UK a decade ago. It was 3 decades ago. It was lovely to hear Minister Freeman put that in his speech, thanks to our DSEC colleagues, I suspect. But actually, not many people know. They think NASA does it. They think the Japanese do it. The UK has built them, and built them really well. And we did it because no one could corroborate the evidence of temperature climate change. And Sir John Horton said, we need to do this from space. So we did it. And we did it for the oceans. So the second point I want to make is that actually things have changed in Earth observation very, very quickly. When these were designed, they were there to do sea surface temperature, but we very quickly realised that we could do land, which wasn't in the original objectives. And land, of course, opens up the door to a whole bunch of applications. We've now built that into our National Centre for Earth Observation. So if you don't know what that is, I know many people do. I just want to say one word about that. So that is the UK Strategic Research Centre funded by UKRI to be part of the brains of the academic capability that you can access. Okay, and so a lot of this work is stuff we've been doing for many years because it takes a long time in terms of research. Okay, so let's just come to the particular examples. So I'm just going to focus in on one example here. In keeping with the times, I've tried to choose a large city, not London, and all the credit goes to my team, not me, but it's lovely to actually talk about some science rather than strategic PowerPoint blocks. So I'm going to enjoy myself here. So here are 4 images of a land surface temperature for Birmingham, derived from Landsat, but for the first time with quality and uncertainty, and I won't go into all of that. They all look, apart from the image for March on the top right, look very similar. And the reason is that there's some cloud in the March image. But, of course, we all know that February is much colder than July. So they all have a similarity. In all cases, the urban city is much warmer than the surrounds. And the question is, what do we do with that information? So what I'm really going to try and do in this talk is actually show some statistics and some geospatial. So here is the statistics, the histograms of temperature for that region that I've just shown on those images for those 4 months. So clearly we're going to see those absolute changes in temperature. February, very nice, tight distribution, very cold, to July on the further extreme, which was, no surprise, part of a heat wave. And you can actually see the green curves for July exceed 40 degrees centigrade in land surface temperature, which is not the same as air temperature, which is something else that we could get into, probably won't. It's a bit difficult on the screen to see, but actually we mark some peaks on there. So that for those in the room, the peak just above 35 is the urban land surface temperature peak. So a lot of the urban areas have got surfaces that are really very hot. Okay, and so you can see that instantly, the first thing you can do without doing anything very clever is, if you believe this data, is you can put some thresholds in and you can say, right, are we above a threshold or not? Does that matter? Who does that matter to? And you can also see that with statistics, you can say what percentage of the region is above that. So you're already getting 2 pieces of information. Is the city at risk? And how do we use that information? How much of the city is at risk? We can obviously then compute some averages over that region, or for particular subsets of the region. So in here we've plotted suburban and city centre, which are the sort of orangey colours, brown colours, and then the lower surface temperatures obviously are the rural backgrounds, or the rural areas. So that in itself already tells you 2 things. Not only can we tell you how the city's doing, we can tell you how the surrounding hinterland is doing too, in terms of a temperature. And so if you're in fields, that comes down to drought, for example, and crop productivity. I won't go into the details here, there's some comments on the side, but essentially the big thing you can see is, again, now in absolute terms, we're seeing the difference between the urban city and the rural areas, or parts of the urban city and the rural, so we can quantify that difference. The lines are misleading because obviously we're only observing at particular times, but they do help you to see what's going on. Okay, so what can we do next? So actually what we do is we take some of that rural information, and what I didn't dwell on there was those rural plots of temperature for particular places. So actually using our optical data, we've defined particular places which serve as a background reference. Actually raises the question of what do we actually mean by an urban heat island. Leaving that aside, if you do the computation now, so we did absolute, then we did how much of the city, now we can actually look at the geospatial representation of that. So the reds here and the oranges are the warmest parts of the city. The greens and the blues are the surrounding areas typically, or green areas within the city. So we can actually start to differentiate what's happening, very fine detail, 100 meters in fact, what's happening within this city scale. It makes for a very pretty plot if you like these sort of plots, but I'm told that a lot of people don't actually like maps. So, for me, it's beautiful. Okay, and the beautiful thing for me as well as a physicist is that I actually understand the process of getting from the image to this data. And I can tell you how good that data is as well. So I can give you some uncertainty bound on every stage of the process. And we call that traceable uncertainties. So, and that's something we couldn't do 10 years ago at this level of detail. People could plot Landsat temperature data, and they've done it for years and said, here's an urban heat island. But you just could not interpret it in a way that could be used either scientifically or meaningfully. You don't just have to use the thermal. I won't dwell on this too much, but I couldn't resist putting this one in. This is actually not the temperature. This is the vegetation. This is NDVI, which in scientific terms is a rather crude measure of vegetation and greenness, effectively. We have much better measures, and we're working on those as well. But the thing I want to point out is the obvious, and one of the things I love about Earth observations is they quantify what is actually common sense. So we know that things are going to be greener in the springtime and late spring than they are in February or in September. And you can actually see these peaks, for example, that come out here are signatures of that vegetation growth and productivity. Now, actually, if I was doing a different talk, I'd be taking that vegetation data and putting it into a crop model and be able to try and predict the crop yield in the Birmingham hinterland. And we can also do things like that. Obviously, there's a lot of R&D going in that area, but we work in that space too. Yeah. Right, I'm nearly there, actually. Okay. So if we look at the differences then in a little bit more detail, in fact, I'm just going to go straight to the next one. On our maps, you'll see actually that structure is quite compellingly similar. Now, one of the problems which has already come up today is this latency point. You know, we can't measure often, we can't measure enough. What this is telling us is actually we don't always have to measure at the point we need to know the information. Now, we're testing this at the moment, but we could measure the information at a different time and project what the effect will be in the heatwave time. And that's really important. That's forward planning, and that's information when you need it. Okay, so let's skip over that. And in fact, we can actually drill down to very fine detail. This is a particular industrial area, Sainsbury's Distribution Centre. There's a hall there where we can actually look at the temperature variation of individual locations. Okay, and so we can work out how they're changing and when they change. And then, having got all that information, what do we do with it? Well, we could put it on our website and we could do things. So, you know, very pleased that we can have the Earth Observation Data Hub, trying to really make that data accessible to you, subject of another talk. But a big national project. It's the first time we've actually done this in the UK at this scale, so it's going to be really exciting to see what happens, working closely, I hope, with the GC to come. But the other way you can do this is get the data to somebody else. And so I'm pleased to see OS colleagues in the room, and I didn't really ask them beforehand, but I'm hoping they give permission that I show this. All right, get a thumbs up, great. Thanks, Matt, Jason. So well, the best thing we did was not to try to show the data ourselves, but to take it to the intermediary people who actually can give that data themselves as trusted organizations. And just by doing this trial of combining the temperature data with the OS data, we were able to get 350, I believe something like that order, people from local authorities, et cetera, actually looking at this data. So that was good. Yeah. So let me just conclude then. Some of this you can read. What I think we've done is we're already showing new ways of determining the absolute temperature thresholds for risk, the way in which those are spatially and statistically resolved. And the question is not so much can we use the data, but who would best use the data and what they actually want to derive from it. The second lesson is perhaps that we don't have to reinvent the wheel. Actually, if we can give people the methodologies and the trusted data, so the data hub for the trusted data, either what we're doing nationally or in our Earth Observation Climate Service for the actual methods, then you can actually apply them much faster and you don't have to go around that cycle. Comes back to the point Daniel made about how do we know the algorithm's working. And I just finished by saying that, of course, it would be amiss of me not to note that in the Climate Change Committee's impact assessment report, heat waves and our lack of response to heat waves and what we're doing about it and quantification of those is one of the urgent actions they would like to see the government address. So, thank you.
Thank you very much, John. Thank you. Okay, so I think we've got, we've had a flavour of, how important Earth observation data is in terms of, informing public policy decisions. And then linking back to what Peter said, and John said this as well, we've had Earth observation data for a long time. It was interesting hearing, the use of Landsat data. So before I go to questions from the audience, I've got a starter question, and I'll go in reverse order of presentations, which is, what are you excited about in terms of what's coming on the horizon in terms of Earth observation data and possible use cases? So, John, you first.
Yeah, well, I think it's just a wonderful time. I mean, if you're a scientist like me, but also if you're someone who wants to use that data, there are just many missions coming up. So even in that example there, just take that one example, we have influenced, Europe, Copernicus, to build a new land surface temperature satellite better than Landsat, using methods that we've developed. And so they are planning to launch that later in this decade. We know that companies in the UK are trying to do thermal sensing and are planning to launch sensors based on UK technologies. So, you've suddenly got all this going on in and that's just land surface temperature. You go to crops, etc. It's naturally exploding field both commercially and public service. And what we want to do is make sure we're really, really embedded in that, I think, to take full advantage.
Excellent. Owen.
I think for me, it's all about capability. So in terms of the ease with which data can now be used and people can pick up these types of technologies, but also the structures. So shout out to David Wood at the back and the government geography profession and the fact that we're really taking seriously putting in place the right structures to ensure that we build the capability within the public sector.
Jacinta?
Well, I think it's a really exciting time to be working in this area. I'm actually not a remote sensing scientist. I'm a statistician primarily. So I'm really excited about, the more training and resources I'm finding that are available for people. So it's not just people in this area that can work on these problems and use them, which I think is really great. So data scientists can learn remote sensing skills and vice versa, and people outside of these fields. I'm excited for near real-time imagery. I think that'll be available for free before we know it. And the other thing is really just to see more end users and countries become more empowered and confident to use this data and these methods. They've been around for a long time and people know about them, but I think there's still a little bit of a step that needs to be taken to be using it more and more for official statistics and for SDG monitoring on a larger scale.
Thank you. And Arman?
Yeah, I would actually say that from the economics and academic perspective, the thing that's really exciting for me is the interpretability of the measures, in particular if we're thinking about trying to measure economic outcomes using satellite data. The main pushback that I've seen to those approaches is basically confusion about how the model is capturing those measures. And so I think that there's a lot of emphasis in the machine learning community on interpretable models and sort of breaking down the model into steps that you can pick out pieces and figure out exactly what they're capturing. And so I think that pushing in that direction makes a lot of sense for economic applications and for policy applications, because then the end users have much more comfort with what the data, like the data product that they're using and how they can use it. And so I see that happening in different ways in the field, and I'm excited to sort of be a part of that.
Thank you. Now, one of the things we've heard from the speeches this morning is the work going on across multiple organizations in the UK to get more data more easily available for multiple uses. Just in the work you've done, what have been the practical challenges you've had to overcome to make use of the data you've used? Jacinta, maybe I'll go to you first.
Well, I think I spoke about it in my presentation, but missing data primarily. So even when you get the images, if it's not a pre-processed product, and I think that's sometimes a misconception that people have, and I was in that boat too, that you'll be able to find a nice filled-in image or already processed product for the area and the time frequency that you're looking for. So just having that learning curve, I think, is a bit tricky sometimes.
Arman?
I would say two things. One is scale. And so if you're trying to deploy a neural network on hundreds of thousands of images and construct a model from scratch, I think that requires a lot of scale that is not even at large research institutions easily accessible. So that was a big part of the problem. And obviously things like Google Earth Engine helped hugely with that, just collecting that data. And then the other challenge, I think, is working across disciplines, because I think that the timelines and goals for academic research, at least in this area, are very different across the disciplines. And so as economists, projects often take several years, and that's unheard of for many other scientific fields. So figuring out the areas where you can find end goals that work on both groups' timelines is a key challenge, I think, to making these things actually work.
Okay. John, what about yourself and challenges?
Lots. I think in the data accessibility, that's why we're excited about both the Geospatial pilot and the EO Data Hub activities, because these are some of the things we're trying to address. How do we make that data much more easy to find, but also actually make it available in these process forms. And certainly that's been a challenge, even for us as experts. We spend a lot of our time downloading data and moving data around and looking for bigger computers to analyze it on. So I think how we get that to work better is really important. I think the other thing, well, two other things. One is, how we help people who are non-expert. That's always been a challenge. It's still an expert field, I feel, very much. And, it's a growing expert field, but it's easy for non-experts. And then I think, finally, I think it is, somebody said to me once, if we only had one, when we only had one satellite, it was so easy. It was just, you just used that one. There was no choice. Now there are lots of satellites, there are lots of products, there are lots of methods, there are lots of organizations, public and commercial. How do we get a feeling for, and make it easier for people to get a quality judgment? Yeah, this is a good product for what I need. And I can just go straight to that, not spend 2 years trying to work it out. If we could crack that one, I think we would really go far.
And Owen.
Data access, I think, is the key thing from my perspective. I mean, it's a perfect segue for me just to talk about privacy-enhancing technologies, but I'll avoid that. But within government, I think platforms is still a big issue in government, and the ONS are doing a lot of work with the cross-government integrated data service new platform, and that's obviously a potential avenue for resolving data access issues. But currently, I think that government is unable to adopt the fail-fast mentality when it's very hard to actually get a project up and running, to get the data to the people who can actually use it. So, as I say, this particular project that I was talking about today, we don't know how successful it will be, but it takes us a long time to even be able to get to the point where we can start assessing the viability of the work.
Okay, thank you. So I'm now going to throw it open to questions from the audience, and then I'll move to Slido after that. So any questions for the panel from the audience? Okay, we've got a hand up there. That's the first hand I saw, so we'll go there. I think we have microphones roving.
I think we maybe need to borrow one.
Oh.
Thank you. Hi, I'm Elishna O'Donovan. I'm in DSIT on the Earth observation team. I had a question slightly prompted actually by what you just said, Owen. I'm wondering, given some of the difficulties with having accuracy of data or knowing what some of the outputs will actually be practically at the end, or if we're talking about missing data gaps, etc., what have been some of the challenges in securing funding for starting these projects to begin with when we're not necessarily confident of what will be the end product? And I'm also saying this as being ex-Treasury, so I know the difficulties of trying to put forward an actual business case on the advantages of data.
I guess I'll pick that up first, but then hand over to others to get their take. So I think one thing, we are fortunate in our directorate in the ONS that we do have somewhat of a remit to explore potential and to fail and to learn lessons. But I think the other really important thing is that not getting 100% coverage in our problem doesn't necessarily mean that the project isn't useful. So that point that I made in my presentation of we might not achieve full automation, but semi-automation is still a massive step in the right direction.
Anyone else want to come in on that?
Can I speak to that as well?
Yes.
Sorry, I've lost audio in the room again. So something that we were looking at when I was at the Australian Bureau of Statistics, it was on a UN task team looking at how you could use Earth observation data for official statistics. And so you don't have to go straight from we collect everything in a survey or a census and now we do it all by satellite images. There's sort of a number of steps to get there. So you can replace, parts of a survey, and Statistics Canada have done that with their crop surveys. Or you can, use the imagery to access smaller and more remote areas that you don't actually go to enumerate in person, or you can validate survey data. So there's a number of ways that you can use it. I can't speak to how you get the money approval part, but there are a lot of useful things you can do with the EO data.
John?
Well, just a quick comment, a sort of UK-specific comment, I guess, is I think we've seen some better working across, maybe better, maybe I'm just more aware of it, but UKRI and the other organisations in government. So, for example, we're running a project at the moment with, I suppose it's now Energy and Security, Energy Net Zero, whatever it's called. But looking at taking the existing observing system for greenhouse gas emissions and net zero in the UK and see if we can build a better version. And it's funded by UKRI. So the key thing is the relationship. So that's one way. It doesn't help government colleagues, of course, to do that necessarily. I wonder whether the other way is to look at, well, two things. One is the success of previous projects, to be more aware of when we do get things to work. I feel in this country, you know, and certainly in our community, we're not very good at expressing the success stories, which have been considerable, actually. Somebody said to me, oh, it's all going badly. And I said, well, you know, 10 years ago, we didn't have Catapult, we didn't have a Centre for Earth Observation Instrumentation. Well, 15. Didn't have anything. You know, people don't pick up those. So I think there's maybe some of the successes and using those in the business case might help.
Any thoughts on this? No. Okay. This is maybe one, I'm taking one from Slido, and this is probably one more for government statisticians or former government statisticians. And Jacinta sort of started covering this. And this is a question about, in the creation of authoritative data, what's the right balance between continuity of time series and the richness of data that comes from new sensors or improved resolution? Owen, I'm going to turn to you first.
I was going to ask if you wanted to answer that, Osama.
I'm the chair, I don't answer questions.
I don't know that my expertise is really in this space, so I'll leave it at that.
I will provide some comments on that later. Jacinta, given your background in a national statistical institution, or do you want to just leave this one to me?
I will answer only to say that I don't have a magic number for like what percentage should be for the I think the trust part is really essential, and I understand the reluctance to move into using new data and different sources. Especially, I know the importance of not breaking the time series and of, you know, engaging with stakeholders who use your data as an official agency. All I can say from my experience of seeing, you know, pilot projects and things being done, and like I've seen Statistics Canada put these things in place for their crop survey. That's all on their website if people want to look at that case. I think it's really interesting. But communication, I think, is really key, both internally, but especially with the end users of your data. So yeah, I don't know what the answer is, but definitely it needs to be something spoken about and, you know, check in along the way as you make that progress.
So I probably should say something as director of the data science campus on this. I don't think it's an either or. You can continue time series while beginning to create new experimental series using new forms of data. Then over time, you look at how your various statistical products are actually meeting user needs. And longer term, you may make a decision to switch off some official statistics productions and move to others, I think is how I would see it. I think Sam's nodding at that kind of, maybe.
I mean, the
I
one
would
thing
add as well
sorry.
to that,
Oh, yes.
if I can.
Yeah.
Just that I think that if you're thinking of machine learning in particular, the ability of those models to work depends on having ground truth data over time, right? Because the relationships can change over time. And so I think in that sense, any machine learning based approach has to have somewhat updated government data to train on.
I'll just add two quick observations on this question, which I think is a great one. At the moment, we are looking at incorporating retail scanner data into consumer price index. Now, the consumer price index, is sort of couldn't be higher profile in the UK with the inflation spike that we've experienced. So, of course, all our stakeholders are really focused on the sort of continuity of time series. So it's a really careful stakeholder engagement, dual running process, testing and, publishing sort of delayed data to show how the two series track. It's this really kind of gradual evolution to get people comfortable. But that's probably one of the most challenging areas I can think of bringing in, more experimental methods at the moment. And we're treading really carefully there, but it's an interesting process and a difficult one. Second, very quickly, is I kind of think people tend to underestimate the value of the new and more granular data. I mean, we have just published back in December gross value added for areas that down to 400 to 1,200 households. And honestly, it took us a long time to convince everybody, even inside the organisation, that there was a demand for this and that this would be worthwhile. But of course, what it enables you to do is draw your own geography to try and get that sense of GDP in granular areas that aren't set by the traditional kind of tiers that we provide. But actually people said, people aren't asking for it. But I don't think that's a good reason not to kind of experiment, because sometimes the demand isn't there until you kind of create the opportunity. Thank you.
Okay, thank you. Okay, back to questions from the audience. There was definitely, yes, go for it.
Thank you. Dan Wicks from Satellite Applications Catapult. A question for Owen. You talked about building capability to address some of these problems. What do you think is the right balance between doing that and working with existing capabilities in academic and private sector communities?
So I think that's really interesting, and I guess it comes to the heart of what's the relationship between government and academia more generally. I think the thing that is unique to our setting and different to the academic setting is that responsibility for stuff needing to be maintained. And this happens across analytical communities. Everyone wants to be in the innovation space, and no one wants to be the person left pressing the button once a month to keep the lights on. So I think that we do need capability within government, but I think that we need to lean on expertise outside. So I think we already do that in our directorate by collaborating with academia and hopefully building collaborations today. I don't think that we are the experts. Certainly, I don't want to discredit my team, but my team rely on experts rather than being the experts. And I think that academia will continue to provide that input.
Does anyone else want to add on that? John, given your links with government?
I think that's something that's maturing at a rapid rate as well. I think they were a lot weaker, the links between academia in the Earth observation space, than they were a decade ago than they are now. And I think that's really interesting. I think we're a slightly different community because we live in space missions, so actually maintaining stuff and doing stuff for the long term is part of the DNA. So we're a bit different in that. But just to pick up Dan's points as well, I think the other thing, though, I observed, there's a lot of commercial expertise here as well. And I was just thinking of your problem, and I think I could have heard 4 or 5 companies talk about your problem. It might have been, hedgerows or palm trees or refineries or building assets, but essentially the same type of problem with the same type of mathematical approach. And I think there is something about how we save time and get to better results quicker with some of the co-working. And I think that includes industry in my feeling. In this area particularly, I think there's a lot of expertise in industry.
Jacinta, having moved from the public sector, from a National Statistical Institute to academia, any thoughts on how we work better together as well as with private sector organisations?
I think, between the Australian Bureau of Statistics and the university, which I ended up going to originally in Queensland, the collaboration between methodology and researchers was quite strong, and they've also done some internships and things like that. They also allow officers like myself to take long-term, sort of secondments and go and do a PhD, and sometimes we come back and sometimes we don't, like in my case. I think, academia, we can learn a lot from the public sector as well and private industry. I've just started collaborating with private industry, and I think the main difference I see in the 3 spheres are the timelines, which I think someone else spoke to as well, because industry seems to be able to and be keen to move a bit faster than, say, academia. And then the public service, you have other constraints on your time and stakeholder engagement and other things that you really need to focus on. So I think clear communication about the timelines and different KPIs that you might have for your jobs. So mine is publications, but internal reports and things have different timeframes. So I think communication, I've said that about a different question too, but I really think it's just so important, especially when you're coming from different perspectives.
And Arman, any thoughts on multiple tribes working together?
No, I think Jacinta really covered my perspective as well, so I'll leave it at that.
Okay, well, with that, I'm going to wrap it up. I'd like to say a huge thank you to our panelists, to John, to Owen, to Jacinta for giving up her evening free time, and to Arman for giving up his sleep time. So thank you very much. Thank you. And I think with that, it's time for some coffee.
So I hate interrupting everybody's coffee and networking discussions. There's a few people just on their way along, but we'll just get started. Thanks so much for joining us this morning. My name is Abigail Page. I'm head of Geospatial Market Policy at the Geospatial Commission. We've heard this morning in the panel and in our keynotes a lot about the public sector use of EO data. And I saw a lot of people scribbling and taking photos of slides, which is fantastic. I hope you got a lot from those presentations this morning. I certainly did. What we want to talk about now is understanding more around what the private sector and kind of innovators in this space think about EO and its adoption and its innovative uses. Just a little bit about the Geospatial Commission. So we are an expert committee in the Department of Science, Innovation and Technology. My team at the Geospatial Commission is focused on understanding really exciting and high potential parts of the geospatial ecosystem. So that includes remote sensing and EO that we're talking about today. How are those markets functioning? How can the public sector act as an anchor customer to further the adoption of these technologies and support and grow the market? My background is 20 years in the geospatial industry, so someone was asking me about that at coffee. I think, as John said earlier, the use of EO and the innovation of that in the UK isn't particularly new, but I think what we're seeing now is really a different appetite and growth of the sector, which hopefully we'll discuss a little bit in this panel, and the opportunities for the UK as well. We're going to follow a similar format to the last panel, so we'll have presentations from our panelists, and then hopefully get into some discussion. Thank you for everyone joining us on the live stream as well. I think we've probably got another equivalent of everybody in this room watching us live. My colleague Amelia is going to be fielding some of the questions from Slido and feeding those to us, so she'll be the voice of the virtual audience that are watching us as well. So just a reminder, if you want to ask questions through Slido, the code is 2187101, and hopefully you've got that on your broadcast there. And we'll also be taking questions from the room, so start thinking about your questions as we go through. So let's get started. I'd like to introduce our first presenter, Aravind, who is the founder of TerraWatch Space. TerraWatch Space is a strategic advisory and comms company specializing in EO and satellite data. Arvind's based in France, so thanks for making the journey here. It's great to have everybody here in person, and has a multidisciplinary background. He's the author of the TerraWatch Space newsletter, which hopefully many of you will be aware of as a good read of everything that's going on in the industry, and also host of the TerraWatch Space podcast. And I just picked out the line here that I really liked around the podcast and newsletter: demystifying EO for all. So I'd like to welcome you up to give us your thoughts.
Thank you. Thanks very much for having me. Yeah, thanks for the introduction. I'll probably give you a kind of a longer introduction of what I do and what I think about the adoption of Earth observation. I think we saw in the morning a few applications of the industry and the technology. I think what I'm going to focus on is a lot more on the adoption side. Next slide, please. So to quickly introduce myself, or should I just do it myself? Sorry. Yeah, it works. Yeah, my name is Arvind, and I'm the founder of Terawatt Space. So Terawatt Space is, as you heard, is a strategic advisory and communications company. And another way of saying that is I'm trying to fill, or the company is trying to fill two things, filling the awareness gap and the adoption gap. So if you look at technology kind of in 3 A's, availability, awareness, and adoption, availability is not something that I'm taking care of. I'm not building anything. I'm not making anything available. But I think that there are a lot of people here and a lot of people in the industry who are making things available that are incredibly impactful and commercially useful for companies, governments, and organizations around the world. What TeraWatch is focused on is more on the awareness side and the adoption side. So the awareness side is where the podcast and the newsletter comes in, trying to demystify what Earth observation means for everybody. And the advisory side is where I work with companies, across the value chain, whether it's, companies that are producing technology or adopting technology or investing in technology. That's kind of what TeraWatch does, and that's kind of the angle that I come from. I'm not a remote sensing expert, but I got into the industry about 7 years ago. And I just got fascinated with the technology, and I was just not sure why it was not mainstream. So I tried to want to make it mainstream. That's kind of what TeraWatch is focused on. You may have come across the market value chain. That's kind of one of the framings. The easy way to talk about it is there's data and then there's applications. But I wanted to go deeper and understand what is really going on in the process of converting data that is being produced from space to the one that is actually creating value or creating impact. And there's also a small commercial angle there, because data is commercialized as data as a service, and then there are question marks about how things are getting commercialized, and that's kind of what I try to position in this value chain. So it's starting from data, and then you have platform where you have access to different types of data, or I think platform also works for analytics, where you have analytics, which is transforming satellite data into information. So, number of buildings, number of trees, things like that. But it doesn't really mean anything. It's just converting the data into information. And then there's insights, which is kind of halfway between analytics and application. Insights is where you kind of, transform something into an alert, or, something you inform people of. The emission has risen, the land surface temperature has gone up, or a graph that you see that we saw in the presentations before. So that's kind of the insights. And then the application. The application is kind of like an end product, right? Like an application, a weather app is an application which you can subscribe to, paying $10 a month or something like that. So that's kind of the application. So that's kind of how the value chain is positioned. So if you were to keep that as, an idea of how the market is positioned, looking at where the adoption is, based on like work that I've done and things that I've seen in the industry, we're definitely kind of past the early adopters and innovators stage, as far as I can see, or we are continuing to get innovators into the industry. But as we do that, we have to think about what it means for the majority of the world, which is kind of what that doesn't use Earth observation today, and they don't like to see all the things that we saw before. They just want answers, right? So they probably don't care about if you're selling data, if you're selling insights, and I think the previous panel touched on some aspects of it. They just want to know, what they need to do. I want to, measure my emissions. I want to measure how the ocean surface temperatures change. Things like that. That's kind of what they want their answers to. And that's where I think there is probably a need for an advisory layer, an objective layer, where instead of, looking at data or platforms, it looks at solving a problem. And solving a problem, or in other words, getting a job done. Whether you're a government, you're an institution, a commercial company, you just want to get your job done. And what is missing is, at least from my perspective, there is an objective entity that just looks at different ways to get their job done for end users. That's kind of state of adoption. And a couple of insights on, well, before moving on, there's just one framework on availability of technology. Like, we should probably look at how to develop more technology or invest in more technologies using kind of frameworks. There's just one framework that I use for climate adaptation solutions. You need to invest in solutions that are good for short-term preparedness. You need to invest in solutions that are good for long-term preparedness, which is more about, where there are climate risks and where we should invest in assets and how to take care of the assets. And that's more on the preparedness side, how we can prepare and anticipate things. And then there's other things on responsiveness, right? So satellite imagery is obviously useful for real-time imagery, whether there's a flood or an earthquake or whatever it is. And it's just one framework for understanding how we can look at developing new technologies, because obviously there is a technological point of view into investing in new technologies, developing new technologies, but I feel like having kind of a commercial view or identifying gaps in the industry probably help adoption as well, because it's from when I work with end users, that's kind of what I understand is they are having gaps in probably getting prepared for how to anticipate climate risks in the next 10 years. And then we can kind of then look at what technologies exist today, and you know, that's a different way of looking at developing new technologies as opposed to investing in technologies because it's going to advance new technologies. So that's just one framework that I use, and I just wanted to point that out. And there are several like this across different verticals, across different use cases. But before that, or to end that, I want to kind of talk about adoption and look at how organizations today, just based on experience and what I see in the industry. Some organizations have a data strategy. You know, they have a remote sensing team, so they're happy to buy different sources of data. They know what they're buying it for, so they just go and sign the contracts with data providers. They already have an in-house team, or they create an in-house team, and they kind of use some sort of a platform to process all the data and, you know, derive the insights. Or there are teams that have product strategy where they don't want to do any remote sensing. They just want to buy off the shelf. But what they care about is the quality, the validity. They want to know what is the methodology. You know, they don't want a black box. They don't want companies to tell, this is your climate risk. You know, this is the amount of trees that have been lost over a wildfire in the last 10 years. They want to know how we did it. You know, that's kind of a caveat in the product strategy, almost as it sounds easy, but that's something that companies are very interested in. And the last thing is hybrid, which kind of is where quite a few companies are today, where they're buying some data, you know, they're running some pilots, whereas they're also buying off-the-shelf products. So that's kind of how the industry is positioned today. And last slide, or before that, on adoption approaches, it's more like, it's again another way of looking at how organizations are looking at things. One is a very solution-driven model where they have something that they want to solve, and they just want to look for a solution there. That's one example. Or there can be a horizontal way where companies look at, this is a new technology. I want to invest in seeing how that improves my organization strategically. You know, you can be an insurance company, you can be a utilities company. You have this technology that is going to play a big role in the future of the growth of your company, and they're looking at it very strategically. So that's kind of the second way. And the third way is very technology driven, and we haven't seen that much, but I expect that to happen more and more, where, you know, we see a complete non-Earth observation company, like an insurance company, making an investment into a company that is building a sensor. We've seen that a little bit in agriculture. So if you look at agriculture, there are companies that have invested in, you know, building new sensors. You may have seen the John Deere RFP. Sorry, you may have seen the John Deere RFP, where, you know, they are looking for satellite connectivity to connect to the sensors that they already own. So, you know, you see some, you know, companies going in that direction, but we have not seen that much, but I expect that to happen. Expect that to happen more in the coming years. Let me end with just this quick framework that I use with end users when I work with end users. This is not a kind of a you know, fit for all kind of a solution. You can kind of take it and leave it, but this is kind of how when TerraWatch works with end users in helping set up an adoption strategy for Earth observation, the step-by-step procedure. I don't think we have time to go into each of them, but then, you know, it's pretty self-explanatory. But I guess what I want to stress is probably step 4 and 6 is probably what's underestimated usually. You know, the education phase is easy, you know, doing a workshop is easy, and, you know, identifying what the needs are, they're all pretty easy. But then identifying the technical feasibility, especially keeping in mind what we heard in the presentations in the morning, the data quality aspect, there are questions that are being asked, right? Like, there is scenario number 1, which is going to cost, you know, $500,000 a year, and then there's scenario number 2 that is $250,000 a year, but it's of lower data quality. They need to understand why and what is the implications of that, and that kind of couples with the commercial feasibility aspect, where people need to know what is the opportunity cost of not doing this, and I feel like there's not enough kind of emphasis put in that direction, because I've seen that when that is being done, or when the benefits are quantified to a level where an organization can see in the next 3 years, if they invest in this technology, they can save, I don't know, $500,000 over the next 3 years. It's more likely for them to start, you know, making making some kind of decision that leads to adoption that is sustainable. That's not just running a pilot, which is running for 6 months and then, they forget about it and move on. But it's something that's more strategic for the long term. But yeah, I'll end there, and thank you very much.
Thanks so much, and a great context for the rest of the discussion. Thanks. Next, I'm going to introduce Robin. So Robin is from Earth Daily Analytics. It's headquartered in Canada. And Earth Daily are a data and analytics company. Robin's role there is developing their machine learning analytics, training capabilities, outreach. Robin's a well-known authority in machine and deep learning techniques for processing remote sense data. I've written here, Earth Observation Evangelist. I'm not sure if that was something that I picked up, but certainly from reading all of the great stuff you've done, I think reads really true, and is founder of satelliteimagedeeplearning.com, so an online resource for people who are trying to make better use of their technologies too. Robin, really looking forward to hearing what you need to tell us about. Thank you.
Okay, so I'll just tell you a little bit more about myself, I guess. So I've got a physics background, like many people in the room, but I now work on machine learning, primarily focusing on deep learning techniques. As mentioned, I work for Earth Daily Analytics. This is a Canadian company. We've been around for, I think, 4 or 5 years, but the plan is next year we're launching a constellation of 10 Earth imaging satellites. These are going to be very high quality data streams. It's spectrally matched to Sentinel-2, but we're going to have 22 channels covering all the way from RGB out to thermal bands, and medium high resolution as well, so 5 meter pixels. Okay, so today I'm going to talk about the potential of AI and Earth observation for a sustainable and resilient future. So what I'm going to do is just focus on 4 key applications and give examples in each how AI is unlocking the power of the EO data. First of all, I'm going to just talk about disaster prevention and response, move on to precision farming and food security, then environmental and biodiversity monitoring, and finally mapping urban change and context. So the first example is around disaster prevention. I would assume that some people in the room are familiar with this map over here. What it's showing actually is the output of a model that's predicting floods under various circumstances. And what's happened here is that we can use machine learning to combine both models of climate and also high-resolution data, topological data, or Earth observation imagery data to predict potential flood-prone areas. This will allow targeted investment of infrastructure and prevention systems such as dams, levees, and drainage systems. Second application in this area I'm going to talk about is disaster response, and what I've got here is an example of how machine learning can be used to identify flooded roads and buildings, and also additionally to estimate the fastest route through those flooded areas. This is actually a competition that was run recently, and as I mentioned, it's not just predicting where the flood is, but also behavior in that flood zone about how first responders can get to people trapped in buildings in the flooded area. Moving on to fire. So this is an example of how machine learning can be used to automatically quantify the severity of a wildfire and the damage that's caused. Some imagery on the right over here. This is Sentinel-2 imagery. This is Purbright Ranges in the UK, and this is showing a fire. I'm not sure which year this was, but nevertheless, I think this is a SWIR image, and you can quite clearly see the fire and also the damage that's been caused by the fire. And what people are able to do is to take those kind of images and train machine learning models, which can then quantify or regress the exact amount of damage and fire severity in those images. Moving on to precision farming and food security. So what I've got here is an example of how we can use Earth observation data captured at very high temporal frequency to get insights into the state of crops and their health. What we've got here is just a graphic which shows captured images over time, and you can see the seasonality effects during the summer months. The crops are vivid, and we could generate this kind of time series, and this will allow insights into what's actually happening with the crops. So for example, we can see there's a dip in crop yield here, and maybe a slower growth curve in the crop growth there. And what's required here is both high temporal resolution and high radiometric accuracy, essentially. And by using machine learning, we're able to unlock automatically the insights in this data and as I mentioned, to get insights into crop health and growth. Is it working? It's gone quiet. Anyway. So precision farming and food security. Thank you. So moving on, still in the theme of precision farming and food security, we can use machine learning to forecast crop yields and identify potential risks to those yields. This will allow farmers to make informed decisions that will enhance our food security situation and also enhance the profitability of those operations. Again, so combining remote sensing data, map data, and performing analytics or processing using neural networks, we're able to develop these kind of visualizations of predicted crop yield. This is from a group at Stanford. Moving on to environmental and biodiversity monitoring, we can use machine learning to evaluate large data sets, and this will give us insights into the health and function of both these environmental and biodiversity systems. This can provide valuable insights for development of sustainable land use practices. And in the images shown here, this is actually from Earth Daily Analytics Agro. This is showing land use or land type classification using multispectral data and very high resolution data at that. And this is allowing to understand the specific makeup of the land type in this area. And this will be extracted using machine learning approach as well. Moving on to biodiversity monitoring, we can use machine learning to generate insights specific to kinds of populations, animal populations and habitats. And this is going to provide crucial information to inform conservation efforts. This is an example from a recent paper where they're actually trying to understand the impact of the environment on butterfly populations. And they've processed the remote sensing data to identify particular types of land cover and then overlaid the data on the butterfly populations onto that to get a deeper understanding of how those two factors are related to each other. Moving on to the final topic, which is mapping urban change. As one of the other speakers mentioned, we can use machine learning to understand built structures, the urban world. For example, this will produce information automatically, which can be used to inform local authorities about changes in planning compliance or identifying illegal structures. Again, this is a machine learning driven approach where we basically take pairs of images captured at different times. Using annotated data, we can train a model which will then identify specific changes in the urban fabric, here producing a change map showing new buildings identified. This is another application. This is about mapping urban context. So machine learning can be used to process high resolution satellite images and identify different groups of areas inside a city. This example is from a recent paper, and this is actually over Liverpool. And by training a machine learning model to identify features in the imagery and then performing clustering, the researchers were able to identify 7 different kinds of area inside Liverpool, from inner city, residential properties, high density urban, and a few other classes. This will allow us to get a greater understanding of the characteristics of different areas in the city and can inform decision making. Just to give a brief introduction to what we're working on at Earth Daily Analytics, I've got an example of 4 applications that are under development. The first is around monitoring aircraft activity, and this is a defense application. The second application is around monitoring unregistered vessels, indicated there. The next one is around identifying and locating illegal airstrips in the Amazonian rainforest, and the final application is around identifying particular kinds of crop areas. I think that's in France. And thank you very much for listening.
Thank you. Great fly through of all the different applications that we could be thinking about. Next, I'd like to introduce Charlie. So Charlie is Planet's Chief Revenue Officer and a sales and strategy leader working in this space. Prior to Planet, Charlie led the global go-to-market strategy for design at Autodesk and has a really strong background, as I say, in leadership, sales, strategy, channel development. We'd love to hear more about what you're working on at Planet, Charlie.
Thank you. Okay, morning everyone. So I'll do a quick intro to myself. But the topics I'd like to cover in this presentation is just an introduction to Planet, who we are as a company, and then talk about some of the partners and use cases that are being delivered through our existing capabilities, and then a quick look at the future in terms of where we're going. So I'm Charlie, based in Oxford in the UK. I was employee number 5 for Planet in the UK 3 years ago. We now have nearly 30 people here, which is great. I have the honour or suffer living in the UK and working in the executive team in San Francisco. So we are a San Francisco company, but really very global presence. So the company was born out of a vision and frustration. So our founders were scientists working for NASA, frustrated with the pace of development of satellites, and had a belief that you could image the entire world every single day from space. So they left with that mission. And the reason they did that is to make change visible, accessible, and actionable. And we're now just over 10 years into our journey, and we went public just coming up a year and a bit ago now as a public benefit corporation. So our mission is not just to shareholders, but also to the planet and to be custodians to stakeholders that to look after the environment and humanity. So there's a number of PBCs now listing this way, but it gives us as an executive team like another frame for making decisions that we need to do well to do good, but it's part of our decision making that we use for guiding Planet. So what is Planet today? So we operate the world's largest constellation of Earth imaging satellites. And we have over 200 in space operational today. And they image the entire landmass and coastal regions every single day. So we have this huge, deep data stack of data. So, 7-8 years of data. We've got over 2,600 images for every place on Earth. And that temporal frequency gives us a better chance of seeing through the cloud gaps that do appear that we heard about earlier. So what does this look like? Because that can be quite hard to visualize. So this is a place you might recognize. And you can see our constellation of satellites that are in a sun-synchronous orbit, which are basically traveling around in low Earth orbit, and they are creating this global mosaic of the planet every single day in 3 to 4 meter resolution. And in addition to that, we have this very high resolution, 50 centimeter satellite constellation with 21 satellites that's offering like up to 9 revisits per day for any place on Earth. So it kind of gives you that real-time visibility to be able to understand how the planet is changing. And we support a number of industries, obviously government, both D&I and civil kind of really very much leading charge, but we see this kind of explosion of use cases within the commercial sector across agriculture, insurance, mapping, energy, carbon markets, finance, insurance. It's not really, I can't think of an industry that doesn't have a stake in terms of their impact on the planet and understanding and making better decisions with their resources. So our kind of new approach, historically, Earth observation imagery has been a scarce resource in terms of not having, and we saw that kind of year gaps in terms of data. And moving to have that global visibility means that every single day we're publishing a new mosaic of the planet. And obviously you can tip and cue between the medium resolution to the very high resolution to really understand change in more detail. But it's not just about the data. We download over 3 million images every single day. It's far too much data to work with. So we started as a satellite company. We're now a data company, and we're transitioning to be a platform company. And our job is to make life easier for our customers and partners to solve problems for the world using our data. So these are the satellite constellations that we have operational. So the Doves, the CubeSats, and then the SkySats, this is the existing fleet. And one of the real innovations in the company was agile aerospace. So it's not like every satellite worked. Every time we launch new satellites, we launch to kind of been 40 and 60 a year just to replenish the constellation. There's always test satellites within that. So we're continually innovating and changing and seeing what works and being able to kind of innovate very, very quickly. And obviously SpaceX and others bringing down kind of the launch costs has really made that much more financially available than it has been previously. So just quickly on new constellations. So we announced 2 new constellations. So we have a very, very high resolution, so 30 centimeter per pixel, up to 30 satellites, 30 captures per day, and within a reaction time of kind of 30 minutes. So kind of near real-time information to see how the planet's changing. And we also have a hyperspectral mission, which we're launching our tech demo for this year, working with the NASA's Jet Propulsion Laboratory, where we're taking the sensor with over 400 spectral bands, and we're going to build a constellation so we can see over 90% of the world's carbon and methane emissions, so that you can make people have the visibility to take action. And obviously hyperspectral has a number of use cases. So it's really all about the industry, the downstream for us in terms of the organizations, the partners, the customers that actually turn that data or those insights into actions that impact the planet. And I'll talk a couple of those. And we have many in the room, and I'm actually really pleased as a Brit to see us kind of innovating in this sector and kind of leaning forward. And actually, one of my favorite examples is the Welsh Government. And if any of you in holiday in Snowdonia, you should go to the CAT, the Centre for Alternative Technologies, where they have a permanent exhibit on remote sensing. And they're doing some incredible work. There's a huge plethora of use cases that they're working on for environment, water, agriculture, like very, very progressive. So I'd really recommend looking into that case study. But just to highlight a few examples. So obviously, sadly, the Ukraine-Russia war started, and that has a huge impact in terms of food security. So we worked with NASA Harvest, where they were trying to use Sentinel data to understand what the actual yield output would be, because it was projected to be very much lower. But Ukraine, particularly during the winter, is very, very cloudy. So they didn't have the imagery they needed to actually model the data set. And through the work that we did, they actually saw that actually, yes, it was impacted, but really just along the front line where the fighting was taking place. And actually the crops had been planted, and they were actually harvested kind of like beyond the different zones. And they were able to see across the whole of the country the different crops that had been planted and estimate yield. Another one example, very sadly, so we had the horrendous earthquakes in Turkey recently, and we worked with a partner, Synthetic, and Microsoft's AI for Good Lab, and within 3 days we were able to do a complete countrywide building damage assessment from using our kind of data and the models that they created, so that you can directly coordinate your resources to save lives, to direct funding, to support those humanitarian efforts. And then another example, so recently in the press, so if you have imagery everywhere for every day, what is it you can actually see? We saw in the news about the Chinese balloon. Well, we have the data. We saw it tracking across from where it launched in China to all the way through. And Synthetic, they just created, within a couple of hours, an algorithm to identify the balloons and then to track it. And then we gave them access to our archive to be able to give that traceability. So a couple of examples, and Arvind talked about this, and one recommendation from today is for his TerraWatch email, is that if you don't already subscribe to that, you really, really should, because there's so much valuable insights across the industry from that. But we're moving up we call it moving up the stack from providing data to, ultimately to analytics or indicators. And what we announced recently is some of the planetary variables that we're creating. So soil water content, land surface temperature, biomass proxy, roads and buildings. And these use our data sets, but they also use public data sets. And these are kind of ingredients that you can put into products that you can then feed into a number of different models. And then recently, a couple of weeks ago in DC, we announced the next 3 planetary variables that we're launching, which is forest structure, forest carbon, and vegetation encroachment, to be able to see and understand change across the planet. So very quickly, that was the intro. I hope that was useful. And my colleagues Fiona and Claire, who have far more knowledge than me, are also at the back of the room. So please say hello to us today. Thank you.
Thanks so much, Charlie. And then finally, we have Kelly. So Kelly is the CEO and co-founder of Agreed Earth. I hope she doesn't mind, but when we spoke, I said I would love to have a kind of SME come on the panel, and she said we're definitely the S of the SME. Certainly small in kind of size of company, but certainly not in terms of ambition. Kelly is a native of Texas. She had her first career in East Asia, helping pharmaceutical companies market oncology products. I love hearing what people have done before they've come into EO and Geospatial. Became concerned about the health of the planet, now an entrepreneur in sustainable agriculture, and Agreed Earth is one of the first startups from Carbon 13, so it's a venture builder for the climate crisis. Kelly, please come and share your story.
Thanks for that introduction. Yes, as mentioned, We're Agreed Earth, and we are working on one of the biggest crises facing humanity globally, and we're starting here in the UK. And that crisis is actually at the crux of 4 major problems. We're talking climate crisis. We're also talking air quality, water quality, and crucially, for everyone in this room, food security. And no, the problem is not carbon. The problem is actually nitrogen. Yeah, here we go. This is the slide that everybody should be talking about. These are the planetary boundaries. And as you can see, the one at the bottom, biogeochemical flows, nitrogen, which we use as a fertilizer to grow our food, is the one that we've exceeded the most and the first. And the vast majority of that contribution is from agriculture. And this is the why. It's because when we use synthetic nitrogen fertilizer, we're basically sucking nitrogen out of the air and using methane and a lot of electricity to do so, which means that the carbon footprint of the fertilizer just to produce it is actually huge. But then the other problem comes into play, and that is that farmers are applying way too much of it and they're using it way too inefficiently. So when they put it on their fields, 50% of it is lost. And that's bad for the farmer's finances, but it's also really bad for the rest of us because that loss goes in different directions and wreaks havoc. It goes into the air as nitrous oxide, which is a greenhouse gas 300 times more potent than CO2, and ammonia, which is an air pollutant, so the local community suffers. And it goes into the water system as nitrate, both leaching and groundwater, which is a carcinogen and is very difficult to get out of the water. And this is killing our waterways, causing hypoxia and dead zones. It's just a huge global problem. What that means is for most of the food we grow, and this can be arable or livestock, the fertilizer used to grow it is a huge part of the carbon footprint of that food stock, around 70%, just in the example of wheat, both from the manufacture and the application. I mean, you could say, well, why don't farmers just use less if they're using too much? I mean, it's a really great question. Ironically, the problem is finance. While it is expensive for them as an input, the problem is that it's actually addictive. Their soil gets addicted to it. It's great at producing yield, but it kills the biodiversity, the microbiome of the soil, which means that they then need to use it to get the same yield, which keeps them stuck on that treadmill. And so if you say to them, well, just use less, they'll go, well, I actually can't afford to because I will have a yield dip for quite a while, and that will kill my finances. And at the end of the day, farmers are businesses. So they're not going to do what they don't see as in their best economic interest, even if it would, in the long run, help them. And therein lies the big problem we all face. They're stuck on this stuff, and therefore so are we. And so our solution, what we're working towards, is building MRV for N, so to speak. So this is using Earth observation data to model out when a farmer applies X amount of N into the system, where does it go? Because right now they are focused on their yield. That's what they look at. But how much goes into the air and how much goes into the water is actually a black box to them. They don't know. It's really difficult to monitor and see. And so they can't change their behavior and make better decisions to lose less and use less over time. And so that's what we're focusing on using Earth observation data. And we're doing that with the generous support of a number of different players, grants from ESA, a DEFRA-funded Innovate UK grant. We're applying for Ofwat, and of course the generous support of Geospatial. Now, what this does, why Earth observation and what it allows us to do, and this is the wrong image for this, but it allows us to look back in time, basically, not looking at space in this case, but looking at the ground and getting a big data set of back data of what's been happening on the ground to then train machine learning AI models on that back data to then predict forward, which is what we really need. And I think a few of the other speakers today have talked about this approach. So I'm going to make it slightly more specific to our case. We're starting looking at the water corner of that triangle, focusing on nitrate. And we're doing that by collecting ground truth data from farmers on what they've actually been doing on their land to grow the crops, using the remote sensing data, and then combining that into existing validated models to then say, okay, well then what happens to that nitrogen into nitrate? How does it get into the water? To make that more specific, we're using an interpolation puzzle piece approach. So here you can see a real catchment area up in Norfolk called the Winsome. And we have really good ground truth data on certain parcels of land for how those farmers were farming it, how much nitrogen they were applying. For the other ones that we don't, we then use satellite data to fill in the gaps using best guess analysis. Then we can create a composite total and map out how much nitrate was actually being applied and then going into the water system in that very important catchment area. It's a chalk stream, so hugely important for nitrate. And what that gives us is a time machine view of the trends of land use and therefore nitrogen application and nitrate loading into the system, which is a wonderful, wonderful data set to then train the model to be able to say, if the satellite data says this, you're probably seeing this much nitrogen and thus this much nitrate over time to then predict out going forward. And this is something that we're looking to do in all the catchment areas around the UK in order to really nail down how much nitrate is being loaded into the water from agriculture and attribute the appropriate amount to it and help draw down. So what that means is this data then gets operationalized into dashboard form to help those farmers see what is happening on their fields, on their land, where is the loss taking place, and why. And it's the first time I'm doing this, so let's see if I can, oh, no, it did not do it. I wanted to play the video. This is a video screenshot of, oops, oh, now I'm really messing things up. Oh no, and now it's over. I don't know how to get the videos to play with the clicker. I showed you screenshots of going through our dashboard and, oh. Okay, yeah, could you, actually the farmer dashboard, can you hit play? It is a video.
It's taking us out to YouTube.
Oh, because it had to be uploaded from YouTube to put it in the slide. I can talk through it. I'll just talk through it. So what this does is it shows where the loss is occurring and why. Is it going nitrate into the water system? Is it being volatilized into nitrous oxide? Which helps the farmers then be able to make better decisions to reduce the loss and reduce the need, the use over time. But what then we can then do, oh, yeah, here we go. Cool, thank you. So this is showing how the farmers can then see on a field level basis, how does that individual field stack up against their overall use efficiency and a regional average, because so much depends on the soil, on the permeability, on the health of it as well. And they can then see the cost of that loss, which right now they're not so focused on. And this helps them make better decisions. What we're also really looking into is how can they use regenerative, sustainable farming practices in a stacked manner to reduce their need for the nitrogen in the first place, rehabilitate their soil, get that natural fertility going again. Because again, this is the real goal, to get them to lose less and use less nitrogen, but still maintain yield and improve profitability, which is to this point, we're helping them revenue stack for the same practice. So they can see on a field level basis, what other schemes might they be eligible for doing the same thing so that they can maximize the revenue, which helps de-risk that transition for them. We remember the yield dip that they're worried about financially. And if you could go to the next dashboard, which then takes it up to the regional catchment area level, which is very beneficial for water companies who then have to remove all that nitrate from the water. This helps them, last slide actually. So that was a map of what we were looking at to pull the data together, and then this is that actual model operationalized into a dashboard form. So same deal, if you can play it, please. Thank you. Yeah, so this is that same catchment area actually modeled out for the nitrogen loading and nitrate loss hotspots. So they can see where the major areas of loss are and quantified, and then understand what is the best way that they, as a company, a water company, can go back to those farmers and help them reduce that loss, which is through providing that farmer view dashboard that helps them with their decision making. So here you can see the nitrogen loading of the different crop planting and land use. And they can run a mitigation scenario to see, okay, well, if we're looking at the high risk oilseed rape, high retention cover crops, what would happen if we did that? Oh, okay, here's our mitigation in terms of both nitrate savings, but also cost savings to us because we're not having to remove that nitrate from the water, which is increasingly a problem as droughts may become more prevalent. And so then they can look at the cost savings of that, and also crucially the CO2e avoided of that nitrogen, which we've just said has a very high carbon footprint. And that is what we're doing to help water, air, food security, and climate and farmers. Thank you very much.
Thanks so much, Kelly. And thanks for our tech team. What brilliant support we're having today. Great, so let's get into some conversation and discussion. Do we know if that other microphone is going to be okay? It should work. Okay, let's try it. I have a couple of areas I want to start us off with, but I really also want to take questions from the floor and also check in with what we're hearing on Slido as well. I just want to take us back to some of the comments from earlier about UK being an innovator, but the pace of innovation perhaps picking up here. And there's obviously a lot of excitement in EO now. I guess, like, why now? And maybe you might have some examples about things that we can do now with EO that maybe weren't possible 3 years, 5 years ago. Like, what is the kind of step change we're seeing, and why do we think that's the case? Aravind, is it okay if I pick on you first to come? You've got a great kind of industry commentary here, so it'd be great to hear your views.
Sure. Check. No?
Yes. That sounds good.
Sounds good? Yeah. Yeah, I think it's a good question to look back in time to identify, because that kind of also helps us visualize what's not possible. I think the big narrative today is, well, there are two narratives really. One is coming from the upstream of our supply side, or another one coming from the demand side. From the supply side, it's more on the, from, you know, what's happening in the space industry, whether it's, you know, in the launch that was referred to before, but also on the manufacturing side, on the sensor side, you know, you have pocket cube satellites, you know, that are really just something that you can hold in your palm, that are able to collect imagery, to obviously the ability to launch, you know, larger satellites, which provides, you know, higher quality data, higher resolution as well. And all of that is possible because of, you know, the launch capabilities. On the demand side, of course, I think climate has been a big push. You know, you can look at climate as an umbrella term. So climate across different industries, you know, from agriculture to insurance to, you know, you name it, also for, you know, governmental use for public services. There's demand coming in from the climate side. So that's kind of what is pushing the, you know, the narrative for Earth observation today, and going to what was not possible 3-5 years ago. I think none of what we are talking about today, or what we talked about today, was not possible, right? Like, we had cloud, we had satellite imagery, but we didn't have that in a way that is as prevalent as today, where you can literally go and access the data and, you know, push it onto your S3 bucket and start, you know, developing algorithms. And, you know, Robin's newsletter is great for identifying, like, algorithms that just already exist. So you don't literally need to do anything. You can just, you know, take the imagery, apply this algorithm, kind of need to know how things work so you know what you're getting, but you can get started. So, you know, I think that's been the biggest push. And what that has led to is the creation of what I call more and more usable and useful data products. So a lot of times in history, we had a lot of useful products from Earth observation, but they were not necessarily usable, meaning, you know, a user who does not know remote sensing, you know, a data scientist, software engineer, someone who's just an analyst working in an insurance company, or, you know, someone working in public services, they could not take advantage of it because they needed to do all those steps. But now you have the ability to do usable, useful data products, and I think planetary variables is kind of one of them, where you can just take that data and understand, probably you need to understand how it works to understand the result better, but you can at least start playing with it to understand the potential of the technology. So I think that's kind of been the big push, but the others might have other comments.
Yeah, Robin, it'd be great to hear from the kind of analytics side of things and where you see the developments that have happened over the last kind of few years.
Absolutely. So I'm going to take a very much machine learning specific focus in my answer here and just say that a lot of the frameworks that are used for training models and deploying models have matured over the last couple of years, and actually many of them were developed like 5-10 years ago, but they're now actually the point where you can like productionize them and build services on them. We've got much more data coming in, resolution, temporal frequency, and high quality data as well, and that's obviously the raw ingredient for predictions and models, whatever. Another point I want to raise is around the availability of training data sets, which if you're trying to train machine learning models is actually crucial. But there's been many data sets published over the years, but the rate and the size of those data sets has just increased dramatically over the last couple of years. People are now creating like foundational models in remote sensing, which wouldn't have been possible a few years ago. And I think we're only going to see more of that. I think that's something the UK needs to do more of, is producing training data sets to enable this kind of modeling with a UK-specific focus, and hopefully that's something we can raise awareness of today. But that's my perspective. Thank you.
Thanks. And I guess we've heard a little bit about the technology side, like Charlie, in terms of like the business models, and maybe Kelly as well, around the kind of opportunities that have been opening up in the last 3 to 5 years. Have you got anything to add on that side?
I mean, just actually quickly on driving the trends, I think COVID gave digital transformation a good push along. We literally got called by people saying we can no longer go out to sites to get the data. We need to be using satellite data for looking for fly tipping or agricultural policy support. So I think that gave a helping hand. And then the sustainability transition, like we are in a crisis, and it's really great to know we have companies like Kelly's like stepping in and providing actual solutions on top of the data. So I think that the sense of urgency is increasing, as well as kind of the timing with people looking at how they can be working is driving kind of productivity gains. And then specifically you asked about kind of the UK, like we have amazing people like Robin and like in the UK with the skills and availability resources and our universities and satellite applications Catapult, and there's actually lots of support here for people to kind of get started. I think we struggle beyond that, but that's probably another question. So in terms of business models, I think this is an opportunity where commercial and academia and government need to work together, because it's like, what are the barriers to actually building new businesses? For Kelly to build her business, like access to all of the data, that's one thing that we can potentially help with, but we have to cover our costs as well. And I think that there's kind of new business models coming where people they want to subscribe to parts of the planet. They want to do rev share where they're like sharing revenue based on an outcome rather than selling pixels. There's different ways of operating with satellite data emerging, but we have in this country, we have the people, we have the research organizations, we have academia, and I think that if we can remove some of the hurdles, we can start to accelerate that further.
Yeah, great. Kelly, do you want to pick up on that?
Yeah, just a little bit, just to build on what Charlie just said. Completely agree. And here in the UK, we are seeing programs like Carbon 13 to build startups to solve the climate crisis, and we're a product of their first cohort and very grateful. And also, and to the point about kind of government-private collaboration, one of the reasons why this is kind of accelerating now is there's this confluence between the crisis and the need for data to help solve the crisis, and the ability to create markets that then that data can feed into. So for example, carbon credits is one thing where we need validation, MRV, and we need the markets to mature, and regulation can help with that, so government role. And where we're working nitrogen, there could be nitrogen credits, nitrogen trading markets, things like that. So that's a real opportunity that I see that the UK could even be a leader in.
Great, thanks. Amelia, I'm going to come to you on the slide in a minute, so just a word of warning. Does somebody in the room have any points that they want to pick up? You look searching for hands. Oh, yep. Bernard.
It's a bit of a cheat because it's the first Slido question as well. Can I first of all say I thought your point about carbon credits is very important. Bernard Silverman, the chair of the Geospatial Commission, but I also have a background, other bits of government, so it's a question for Planet, and it's about how do you, what did I say on Slido? Everyone's voted it up. How do you make sure that the bad people don't get use of your data? Because I mean, you mentioned the Ukraine war, but your stuff would be an absolute gift to someone who wanted to know where to drop something, etc.
That's a great question. Before I joined Planet, I actually asked the CEO what processes we had around ethics to actually make sure that like individual salespeople aren't making decisions because they might not be aware of the geopolitics of a particular situation. So we have obviously strong compliance and regulation, you know, found it like within our organisation that everybody has access to, as well as an ethics committee. So anything automatically that looks like defence and security is always referred to ethics before it gets to a certain point in the process, so that we can actually review, you know, whether this is actually good for society, for visibility, for to have that access to our data. So transparency is kind of a fundamental value of our organisation, and our belief is that actually by providing more visibility about what's happening in the planet, you can actually shine a light on activities and hold people accountable in a way that you couldn't before. And you know, the Ukraine war is a very sad but a good example of that. When the Russians denied they were about to invade, and we saw the building of the bridge over the river in Belarus, the Americans or others used that non-classified data source to point to what was happening, to show the world that this was about to happen. Unfortunately, it didn't prevent the situation. But it's something I personally take very seriously, being kind of the custodian for the commercial team. And it's probably not something we can avoid ever getting wrong, but it's something we have kind of strict policies and processes inside our organisation to make sure that we're helping people not put our customers or the world in a worse situation through the capabilities we offer.
Thank you.
Okay, can I just, so may I?
Briefly, sorry.
Very briefly. Yeah, well, we should talk, but of course it raises all kinds of other questions about, you know, who makes the decisions and so on and so on. But do you have a system where you have kind of course level data that's available to anybody, but fine level you have to be someone, or does it all belong to you, as it were?
So you have to have access to our platform to be able to get access to the data.
Right. So
and we all have regions of the world or areas that are restricted.
So you vary.
Sure.
Yeah. Okay.
And we
thank you.
verify that. Yeah.
Thank you. Thank you.
Great. Thank you. I'm going to come to Amelia. If you don't know Amelia, she is our heading up our Earth observation pilot at the Geospatial Commission, which is all about seeing the public sector have access to EO data. So if you'd like to know more about that, please catch Amelia over lunch. We'd love to discuss that with you. But Amelia, have you got any questions coming through on the Slido? Bernard's already read his out, which probably helps. What else have we got there?
Thanks, Abby, and thanks, Bernard. Why, yes, there are more questions on Slido. So this one that's now top voted, navigation/location-based solutions have made GNSS and GPS services mainstream. What's the killer use case that will take EO from niche to mainstream?
Oh, I like that question.
Outside of military and defense.
So the killer use case that's going to really see EO become mainstream and adopted. Who wants to pick that?
Yeah, I think the answer is probably going to be what you expect from a consultant. It depends. And it's probably not going to be one. I think we probably are barking up the wrong tree if you're looking for a killer use case in Earth observation, in my opinion, because we probably shouldn't look at Earth observation as a market where it's going to be dominated by, you know, one use case, which was the case for GNSS, which is location-based services, you know, which is one of the use cases of GPS, and that is the biggest kind of revenue share for the GPS technology on the whole. So you're looking at Uber or, you know, any kind of mobile-based services. They are all location-based services, even though GPS has other, you know, technologies or use cases. You know, radio occultation is a use case of GNSS, right? So we don't really talk about it much, but then location-based services occupy that mainstream talk a lot. But in Earth observation, because of its horizontal nature and its contribution to different industries and different use cases, I think there will be almost a spectrum where I'm trying to kind of develop that internally to see the level of impact for a ise case from satellite-based Earth observation is going to be different across different use cases. And there's going to be a variable by vertical, but then there's also going to be a variable by geography, where there are going to be places in the world where we're going to have a lot of ground truthing data, or today the job is being done by ground truthing and satellites are going to be complementary. Whereas there are parts of the world where that data doesn't exist. I mean, there are people here who probably know that, you know, very well in terms of availability of data around the world. And in those cases, the level of impact is going to be extremely high. That is probably not going to be comparable to what probably we see in the Western world, right? So I think it's probably not right to look at it as mainstream. I mean, for conversational purposes, you can probably argue UK being kind of the center of finance for the world, there is a big push in terms of, like I saw the climate umbrella term before, so insurance and climate risk, which kind of also couple that, and you can kind of apply that across different verticals, right? Like agriculture, insurance, or whether it's carbon credits, that's also kind of the financial services market. So that is kind of where I think a big opportunity is, and also for UK to lead, to be honest, because a lot of that domain expertise exists. And one of the biggest problems in Earth observation is the domain expertise is not there, and there is the technology. But financial services is one industry where the domain expertise exists. We just need to see where satellite data can come in and enrich the applications that already exist.
Does anyone have a different view? Is there a killer application? Robin, what do you think?
So I guess what I'm hopeful for is that the challenge in the past for accessing or using this data is there's a high technical barrier to using it. You have to know how to do a geospatial query or have some system built, and I'm hopeful that through advanced analytics and machine learning, we can actually extract useful information out and present it in a much more consumable way, so we can actually take it mainstream. So for example, you'd actually be able to get an insight into the carbon footprint associated with your meal, right? And it will be personalized to you, but it will be facilitated by this improved interface enabled by new approaches. So that would be my take on what I think is happening.
Nice. Should we go pick up another question? Matt at the back. Can we pass the mic back to? Thank you.
Morning. Thanks, everybody on the panel. That was a really fascinating discussion. I wonder if we are at a risk of slowing the rate of adoption for Earth observation by treating Earth observation as a separate silo to a wider data conversation. What's the reaction from the panel on that?
Still too siloed. What do you think, Charlie?
So do you mean because we're not integrating other data sources to the conversation, or how do you mean?
Yeah, I mean, we talk about Earth observation often as an individual sort of discipline of data and services. And is there a way for us to think about this separately, or in a wider context, I guess, rather than just about EO and the role that EO plays, but how do you put that into a wider data conversation? And do we spend too much time thinking Earth observation is unique, I suppose?
It's a great question. I mean, I was thinking actually about the question before about kind of the killer use case, and it's actually that I kind of see Earth observation just underpinning everything in terms of the way that we work. So, and it's less of, and it's one of the feeds. And Kelly's business or agriculture businesses, that they don't just use Earth observation data. They need weather data. They need GPS data. They need all local mapping information. There's so many different data sources that are needed. So, I'm obviously up here representing one of the companies that capture data about the planet. But there's this incredible downstream ecosystem that needs to still be developed to leverage and combine different data sources to solve the problems with the data. Kelly.
And you might think that we pre-coordinated this, but we didn't. But building on Charlie's answer, I think one of the ways that we can facilitate that is I think it is unique in the sense that most people aren't aware of it, don't really know what it is and what it's capable of doing, and it often comes in the form of something that sounds very esoteric like NDVI, which is something that can be translated into something meaningful, but you need to know the relationship and how to make it meaningful. And so there's a whole lot of awareness that probably needs to be raised about what capabilities exist and are coming to further facilitate bringing it out into all these different use cases like agriculture and other verticals.
Great, thank you.
I'll just add as well, one of my favorite bits of Kelly's presentation was the numbers. These farmers are running businesses, not deliberately harming the environment, but they need to be shown the impact that it can have to help them adopt that. And it's very hard to take an image from a satellite to get to creating numbers in terms of what's the impact on your business and your livelihood. And that's really, really important in terms of actually making Earth observation fully mainstream.
Great. I'm trying to be democratic. I don't want to hold people back from their lunches. Could we take another? Is that okay? I want to just take one more question from the Slido. We've had two in the room, and is there another one there, Amelia?
Yes, there can be. I need to adapt slightly because we've discussed the mainstream point. Okay. But essentially, I mean, near real-time and spatially granular monitoring from EO has the potential to really bring home the value of the technology. And I'm thinking in Aravin's presentation about the points around demonstrating commercial feasibility and technical feasibility. What does the panel think are the main steps we need to take to address that?
So the question about the feasibility there on how we pick that up. Do you want to comment?
I think I'll probably just say, I think the discussion that we're having in the room is probably a good example of that, where we have, I'm guessing, presence of academia and research, we have presence of the public sector, and we have presence of the private sector. And I think all three are somehow needed for most of the use cases that we're talking about in Earth observation for conducting those feasibility, because companies need to build a product that have a demand, and that demand in some cases, or increasingly in most cases with Earth observation, is derived from regulation, and what kind of regulation comes in from the public sector. So I think all three kind of stakeholders need to be part of that conversation for most of the use cases. But specifically for conducting the feasibility, I think it goes back to one of the previous questions that was asked about how this should not be a silo. And I think my answer to that was going to be, if it is going to be a silo, it will not be adopted unless it's kind of integrated into some sort of a use case or a job to be done that is already being done, or a data strategy, or as Planet calls it, digital transformation. And I think you have another transformation, sustainable transformation, I think. So it needs to be part of some sort of a narrative, and usually that's what usually gets the kind of the decision makers to take notice and understand the technology. Because if it is a silo, maybe it leads to a few pilots, because here's a new technology, let's try it out kind of a thing. That's what will happen if we keep pushing the silo. But if we kind of have an integrated narrative that is within the use case, within a job to be done for a company, it is more likely to be adopted. And feasibility studies help get there, and that's kind of a step to get there.
I just have one comment, is that, I mean, we see an explosion of use cases and people kind of testing and validating different things, but just because it works doesn't mean people will change the way they work. And there's actually like a we're talking about people fundamentally doing things differently from how they've done before. And that sort of change is hard. I actually think that's where the UK has a unique advantage, because one of our greatest industries is the services industry. And we have consulting and expertise that we can help support businesses around the world. There's no barriers with Earth observation. It's fully global business in terms of what do these businesses or governments or organizations, institutions actually need to do to change the way that they work to leverage the benefits of observation. And the last thing is, like, these studies that are happening, they're often very technical in nature, and actually then going back and like, what is the return on investment for that? And I could just give one example, which is, we're working with the Polícia Federal in Brazil, and they've been using our data to help make interventions in real time when people are looking to do illegal deforestation. And they've documented 1.9 billion in benefit that they've received. That's a 5,000% return on investment. Okay. But if they hadn't done the work to do the study, that's not a known figure that you could take back to anyone to justify why would you continue with this research or this project.
Great. I'm aware we're heading towards the end of the session, so I'm going to use Chair's prerogative to ask a really big question and ask for the one-line pithy answer from each of you. So we know that we've got a mixed audience here from public sector, private sector, people that are adopters of EO, but also some people who are looking to get started, and particularly in the context of what we're doing in the Geospatial Commission as well. Can you give us a one-liner piece of advice? Where do people get started with EO? What should they do first? How can they kind of unlock that value? Kelly, let's start with you and then move along the line.
I mean, I'm going to answer from an entrepreneur's perspective, which is find a problem that you're passionate about, that you really want to solve, and figure out what way could a big data set, just if you knew this thing, it could help solve that problem. There's probably some Earth observation data set that could help you do that and scale it. Scalability is key, obviously, for entrepreneurship as well. And so I come at it from that angle.
I would say if you have that idea, then look for the resources that are available to support you. So look at the Satellite Applications Catapult, look at ESA's EarthNet program, look at providers like Planet and others in terms of what they can do to support you with developing that idea.
So I would just say to work on communication, because there's plenty of people in the world with lots of problems. They don't even know that remote sensing data and machine learning could be a part of the solution. So just communication is the first step in building that bridge. So Thank you.
I'll probably just say, understand the job to be done and the role of Earth observation within that, not just the role of Earth observation, but also the impact of Earth observation. So if we use this technology, what is the impact? And I think it goes back to the ROI comment. And if it's understood, I think then, it's easier to get the money, and it's also easier to kind of get the people in to start working on it, because you're building for something to get some sort of a job done that will definitely be useful for somebody, instead of starting from a very technical point of view. Not that it's wrong, but then it probably won't lead to commercial uptake. It leads to scientific advancement, but that is not, especially not commercial uptake. So job to be done.
Fantastic, thank you. Can we thank the panel for all their contributions today? I'm just about to hand back to Sam to close, but before that, I just want to acknowledge the fantastic facilities that we've had here today at Geovation, and thanks to use of all their coffee machines and things. I think we've got a representative from Geovation. Do you want to just tell us a little bit about the hub here before we close?
Thank you. Thanks. So it's great to have you all here. To your last question, if you're starting something on Earth observation, come to us as well. We have a great community, and we are Honor Surveys Innovation Hub. So what we do is we work with startups, and we enable innovation that uses geolocation data. And obviously, Earth observation is included in that. So we help startups developing, growing, and scaling up. You're more than welcome to come in as well. So do join our community. We have over 1,800 innovators. We have a range of hubs dotted across the UK. And we also have a PropTech and Geotech streams of acceleration, again, in the UK. So far, we have helped over 160 startups. They have created more than 1,500 jobs in the UK, all based on geolocation data. And they have raised more than £170 million to develop. So that's pretty much it. So please do join as community members, or if you just want to have intros with startups or want to speak to startups that use Earth observation or any other geolocation data. Thank you.
Thanks so much. Sam, can I pass back to you to close?
So it's a great pleasure to really bookend today, and it's been fantastic. It's exactly what we hope to get out of the session today. So look, thank you for bringing your energy and your questions and curiosity to this fantastic event and this fantastic subject. Very quickly, a couple of things that stood out for me, or possibly three things. The first is the huge breadth of application. I mean, we've heard about thinking about it in terms of, agriculture, about climate, about humanitarian applications. So there's that massive breadth that's really come across from the great presentations we've heard today. I think another thing that's really stuck out for me, particularly with this last panel, is that journey from the technology and the data we can get from it to application, and what that takes sort of technically, in terms of platforms, in terms of communication, the machine learning that you've brought to, the problem. But, that is a big evolution of getting from the sort of the technological possibility to the usability, and, the guidance for the decision maker on the ground, ultimately. Final thing is just to end where I began about the huge opportunity here. I was quite struck by the theme that came through about actually how long this data has been around, and the fact that this opportunity, dates back to the sort of mid-70s. So I suppose I'd sort of finish just on saying that let's hope after this slow incline, we're just reaching that bit of the curve where it, shoots off asymptotically. So that's my word for the day. But look, thank you so much again for coming, and I'd like to reiterate my thanks to Geovation for the fantastic location we've had today. It's been very convivial for the conversation. Thank you to Peter for your speech earlier, And I know he's left us now, but also to our new Minister for AI and Intellectual Property. Thanks to the Geospatial Commission, my colleagues at the ONS, and the colleagues at the Catapult too, for all the hard work behind the scenes to ensure the event ran smoothly. And it would be wrong of me not to say thanks to you two for keeping everything running so seamlessly. Thank you very much. Look, please stay. Please take advantage of the lunch and continue the great conversations that have started here in the room. Thank you very much.